Welcome to Day 7 of the Viva Supplementary EES hearings. Only one preliminary matter for the committee to deal with, which is the venue for the last day of closing submissions, and we think that should be in Geelong. So, Mr Chessel, if you're able to pass that on to your team just to extend that booking for Deakin.
Yes, we'll do that and confirm that that's occurred.
Are there any preliminary matters for the proponent to raise this morning?
No.
Any for the school?
No.
Or the EPA? Okay. Then we're in your hands, Mr Chessel.
Thank you.
We've got that list of relevant documents that you sent through either last night or this morning.
Yes.
And we've got some of those open and ready to go.
Okay.
So we'll be guided by you.
Thank you. We'll move to the evidence of Dr Wallace shortly. In terms of the documents, I'd recommend that you have access to Technical Report A, to document number 27, which is Dr Wallace's witness statement, to document number 69, which is Dr Wallace's response to the Stantec material that was filed in response to the IAC's request. Document number 88 is Dr Wallace's presentation, and that's the document that he'll be speaking to today, and we'll have that on the screen. And then the other two documents that I think would usefully be at hand are documents 59, which is the conclave statement that Dr Wallace prepared with Dr Edmonds, and document 79, which is the conclave statement for the hydrodynamics that was referred to yesterday, which Dr Wallace participated in also. I said yesterday that we'd go straight to the evidence of Dr Wallace, and that's my intention. I would just start by making the observation that Dr Wallace's evidence concerns recommendations 1, 2, 3, 4, 5, 6, 7 and 8. To date, in respect of marine impacts, we've heard evidence in respect of recommendation 2, that's the hydrodynamic modelling update, and to a lesser extent, or at least partially, in respect of recommendations 6, 7 and 8, which concern the dredging impacts, and yesterday we heard evidence in respect of the modelling components that informed that part of the assessment. So obviously there's a lot of ground for Dr Wallace to cover, and I'm very keen to get to that evidence shortly. The one thing I did just want to understand before we started with the witness is whether the committee has a view about whether it would be desirable for Dr Wallace and Dr Edmonds to come back together in the same way that the other witnesses have after.
We think that the evidence, the range of the evidence is very broad,
yeah,
and that would not necessarily result in any efficiency. So we were planning on dealing with this in the almost traditional way,
okay,
albeit that we're theming rather than doing one case after another. But so
yes,
the normal.
Okay, so we'll hear Dr Wallace's evidence in chief, and then cross-examination, followed
then
by questions from the committee.
We'll put some questions, and then there'll be a re-examination opportunity.
Okay, excellent. That's clear. Thank you. Dr Wallace, can we start, please, by can you share your screen so that you have your presentation ready to go? Okay, excellent. Dr Wallace, would you please state your full name?
Ian Jeffrey Wallace.
And Dr Wallace, what role do you hold at CEE, that is Consulting Environmental Engineers?
I'm the Director and generally the Project Manager for Environmental Studies.
And do you have your microphone on? Is that?
Yeah, I do. Should I speak up a bit
Can you
more?
hear okay?
We are in a situation where everyone is having to throw their voices. So the microphone will pick up your voice on the recording for the people listening online, but it's not of much assistance for us in the room. That said, if you do, like I am, lean close into the microphone, we do hear you a bit better.
Okay. Now, from where do you conduct your practice, Dr Wallace?
Our practice, the headquarters are at 150 Chesterville Road, Cheltenham.
You've prepared a witness statement for the purposes of this committee hearing that's dated November 2024, is that correct?
Yes.
And on page 3 of that document, you set out your relevant qualifications and experience. Is that correct?
Yes.
Can you please explain to the committee what your relevant qualifications are and what experience you have in conducting assessments of this type?
What experience I have in work of this type? I've been working as an environmental consultant for 30 years. I've been involved in a large number of studies in Australia, New Zealand, England and the USA, which has covered similar ground to this, discharges from power stations, discharges from wastewater treatment plants, the effects of those discharges on the marine environment, working out guidelines, including one for the EPA here, the guideline on risk assessment, which you see published on the EPA website. That contains a case for freshwater at Beechworth. That was done by our firm. It contains a case for marine risk assessment at Black Rock. That was done by our firm. I served on the board of the EPA in the Northern Territory, where we assessed all the EESs for the Northern Territory, which covered a range of projects, but many of which had a marine aspect. And so during those 7 years, I believe I assessed at least 50 EESs prepared by others. So more or less doing the same role as the committee is doing here, trying to see the bigger picture. What are the significant risks? What are the things that might go wrong? How can they be managed? So yes, I've worked on Port Phillip Bay studies, Western Port Bay studies, Corio Bay studies, lake studies, salinity studies in northern Victoria, the whole of the Murrumbidgee Basin study, and quite a few environmental flow studies in New South Wales rivers. So in most of these works, you're working with a team, right? These are not done by one person. There's a team of people, all of whom are making valuable contributions, but someone at the end has got to put together the line of logic that leads to the outcome and expresses what are the significant impacts that we as the consulting team see as most important.
Can you please explain your relevant qualifications, identify what they are and how they're relevant to the tasks that you perform for the purposes of this environmental effects statement?
Yes, I have Bachelor of Engineering, a Master of Engineering Science, which was done in London, and it's on river meanders and how rivers behave, and a PhD from Monash University. The topic was Rationale for a Water Pollution Code, which took into account how you integrate the biological, physicochemical and social components of a project to come out with the answer.
Now, do you have any modifications or corrections that you would like to make to your written statement?
None yet.
Now, you also prepared a document in response to what I'll describe as the latest response from Stantec. That's correct, isn't it?
Yes, that's correct.
And do you have any corrections that you'd like to make to that statement or that document?
No, I do not.
And are the matters of fact that you express within those two documents correct, to the best of your knowledge?
They are correct to the best of my knowledge.
And are the opinions that you express in those two documents opinions that you genuinely hold?
Yes, they are opinions that I genuinely hold.
Now, Dr. Wallace, you also participated in 2 conclaves for the purposes of this hearing process. That's right, isn't it?
That's correct.
One with Dr. Edmonds,
yes,
and the other with the other experts in respect of hydrodynamics. That's right, isn't it?
That's correct.
And you prepared, along with the other experts, prepared 2 statements?
We prepared the statements collectively, and
Yes.
and reached a compromise agreement on what were the outcomes of the conclaves.
Okay. And do those documents reflect your views?
Well, they do. That was the compromise that was reached, and I signed it, and therefore I have to stand behind it.
Yeah. Okay. Well, we'll come to the detail of that in due course. Now, Dr. Wallace, you've prepared a presentation to summarise the evidence in respect of this matter. Before we turn to that document, can you please explain to the committee what role you played in preparing the marine impact assessment that accompanied the environmental effects statement, that is the original environmental effects statement, and what role you've played in preparing the marine impact assessment in respect of the supplementary statement?
Okay, the role was similar in each case. We have 3 teams who do the work, and so there's one team who are marine biologists who do the seagrass surveys, the seagrass interpretations, come up with summary documents as to what they've seen and how it can be recorded and summarised. There's a second team that do the field surveys of temperature and salinity and plume extent and so on. There's a third team who did the mussel surveys, in each case collected mussels from Port Arlington, brought them to the site and deployed them, took them to the chemical laboratory for analysis. So there are 3 teams. Each team then prepares a draft of various sections of the document. I set out what I think are, well, in our case, we set out the document to respond to the 8 recommendations. And so each team wrote their draft under the 8 recommendations, and then I wrote the final draft, trying to integrate the various sections and cross-reference back to the EES, and that's the documents that's before you. So I was the project manager, but others did a great deal of the field work.
Okay. All right, thank you. Now, Dr. Wallace, I'll invite you to address your presentation. As you move through, there may be matters that I'd like to put to you in detail, but I'll invite you to please now turn to the presentation that you have before the committee.
Thank you. Thank you for the opportunity to provide the committee with our perspective on the various issues that are before you. And I start with this image which shows Corio Bay, the area that we're talking about. And you can see that it has large seagrass meadows close to what I call the western shore, and close to the eastern shore, and extending into Limeburners Cove, which is on the north. And a second very important feature of this part of Corio Bay is the eastern shore is in the Ramsar site, which I note through the recommendations, and I think everybody would expect deserves special protection because of its Ramsar status. Contents of the presentation is to summarise the work that we've done and the outcomes for recommendations 1 to 8, or Minister's Directions 1 to 8, to respond to the peer review by Stantec and other comments, which is the second Stantec letter and the comments that came up in other expert reports and in the conclaves, to make suggestions on 2 mitigation measures for consideration by the committee. So recommendation 1A, 1B. You know the recommendation, and the way we read it is to better establish the existing environment, to establish the impacts of the existing wastewater discharges, and the establishment of this existing environment is qualified by to enable a better understanding of project impacts. So this is not a study of the whole existing environment, it's a study of the existing environment with reference to the project and the potential impacts. There were further guidelines which said, look, you've got to look at intertidal, littoral and subtidal habitats that could potentially be affected by the project. So that's the same as the first paragraph. And update the seagrass mapping to include the intertidal zone and information on the different seagrass species. And I believe that's exactly what we've done when I show you the seagrass map that we've prepared.
Before you move on, Dr. Wallace, what are the key project impacts in your view, and how did they inform your assessment of the further survey work?
Okay, let's divide them into two groups. One group is the impacts of the existing discharges, and the two stresses in the existing discharges are the rise in temperature and the discharge of chlorine. And we did a lot of work. You'll see we conducted 6 intensive surveys to go and measure the extent of the temperature rise, and we put in some work in the EES to establish what is a design guideline value, DGV, for temperature in relation to natural variations. So we're saying for Corio Bay +3 degrees, because that is the difference between the 50 and the 80 percentile of the natural temperature variations in the shallow water. For chlorine, there was some numbers suggested by the previous IAC that was modified by the EPA during this project, and we've adopted the modified values, which are 10 microgram per litre for 95% species protection and 4.3 microgram per litre for 99% species correction. And the 99 species correction applies to the whole of the Ramsar site, and the 95 applies to the rest of Corio Bay, which is obviously important, but is also a port area and a slightly modified environment. So the result of that field work was to produce an envelope of the extent of the plume. So we took the 6 sets of measurements and said, what's the highest temperature at each site in Corio Bay, and used that to plot an envelope with contours of the 3 degrees. So it's not a plume that occurs at any time. Typically the plume at any time is 30 to 40% of the envelope. But it is the area of potential impact, which I think, or I believe, meets the wording of recommendation A, the extent of potential impact of the project, and the project involves continuing discharge through the 4 existing refinery discharges.
Dr. Wallace, just before you go on, I think you've answered half the question that Mr. Chessel put to you. I think you said, in terms of what are the project impacts, you said there are 2.
Yep.
One was impact of discharges, and you said there were 2, rise in temperature and the chlorine. What
Yep.
was the second set?
The second set of impacts arise from the dredging. So there's an 8-week dredging program proposed, and the stresses from that are turbidity, reduction in light availability at the seabed, and some settlement of solids during the dredging process. So there are a separate group of stresses, and we've addressed them by modelling, which has been discussed a bit so far, I believe. Sorry, I wasn't here yesterday. And by comparing the modelling results that we have with what happened in a previous dredging program in Corio Bay, because we think it's more important to have a model that can be validated against previous actual turbidity results than to explore thousands of possibilities and not know which of those really applies. So ours is a much more focused model. So in summary, existing discharges and with 2 stresses, and the dredging, which has also got 3 stresses. Thank you. On this slide then, I'm just saying we did a lot of work as part of the EES. So there was a great deal of survey work, and the 3 teams were busy down there for months and months. There were 6 surveys of the extent of the existing plumes. And each survey involves about 1,000 temperature measurements. And they have to be made in very shallow water, so that you need a team of people on kayaks, because there's only a small amount of water between the surface of the water and the top of the seagrass, so you can't have a boat in there. So that's how we did it, and 1,000 temperature profiles takes a long time, even with a couple of people doing them. We did 5 kilometres of underwater camera tows, and there's an image about every metre along those tows, so there's 5,000 images. We have provided a summary copy of those images in PDFs, which are, if the committee wants to look through, that at least is a quick way to look through it. And we have also provided the original images, which I think you'll struggle to look at because they're about 1 gigabyte each, and most computers won't load them up. So they're hard to move around and hard to look at. We did surveys of the intertidal and shallow water seagrass and algae. We took a lot of photographs using drones to get complete images of the nearshore and intertidal areas. And the drones take roughly 10,000 photographs when they're flying around on a grid in the area. And we send those photographs to a laboratory in the United States to be carefully rectified to make a complete geo-referenced image of the area. And so we have about 10 sets of drone photographs. We measured the background suspended solids concentration in Ramsar, because obviously that's an input to the model. I will point out that we added the background concentration after the modelling, right? So we do the modelling, which is what's the increase in concentration due to the dredging. Then we add the background and say, so that's the total concentration. And then we assess the effects based on the total concentration and how the total concentration reduces light. And then we put in quite a bit of work to summarise the daily discharge monitoring data. So this is looking at the 4 discharges and what's the temperature in the discharge and the chlorine in the discharge, which are monitored either daily or weekly. And you can look in the EES, figure 582, for example. In the EES shows you 2 years of data of the chlorine discharge in, I think, W1, one of the discharges. And you can see how it varies. And I point out that we use the 95th percentile of the chlorine in the discharge. Didn't use the average, didn't use the median. We've used the 95th percentile. Now, when you look at the distribution, you can say, well, that's not so dramatic, because most of the numbers are between 20 and 30 and 40. So they range from 20 to 40 microgram per litre. And we've used 40 microgram per litre in the modelling and in the assessment. So that's so we are producing a realistic but conservative estimate as to the extent of the plumes. And you may have looked at those little green plumes of chlorine at the 4 discharges, and they are calculated on the basis there's 40 microgram per litre in that discharge, and I think one of the others has only got 18 microgram per litre, W3. So that's how we did that.
Yeah, sorry, Dr. Wallace, I didn't catch the figure number where that was presented.
Figure 582.
Figure 582, and is that technical report A?
No, that's in the EES.
In the EES.
But in technical report A, the same data is summarised in, there's no figure, it's in a table this time. That's in table 3.1 on page 323. So that shows you the 4 discharges, the volumetric discharge rate, the 95 percentile temperature rise, the 75 percentile temperature rise, and the same for chlorine. The 95 percentile chlorine concentrations, which I've got them right in front now. For W1 is 20 microgram per litre, W3, 18 microgram per litre, so that's the lowest. W4 and W5 are both 40 microgram per litre. And then one of the later figures, I give a schematic and I'm using 40 microgram per litre. In your mind, you can divide it by 2 to think of W1.
Could I just ask a question about the chlorine? Is chlorine added by dosing, or is it by, I think when we were on our site visit, we had some discussion around a process of electrolysis?
Yeah, so there are 2 ways to do it. And the normal way to do it, which is what they do mostly, is you put an electric charge through the salt water and the sodium chloride molecules break up into 2, sodium and chlorine, right, because it's not attached to sodium anymore. And so that produces the chlorine dose that you want. They monitor chlorine at the far end, which enables them to adjust the electrical current so that you try to minimise how much is coming out but by doing that. And sometimes that doesn't work, it requires maintenance or something fails. At that time, they add sodium hypochlorite, just like people do to their swimming pool.
Yep.
So they do use both, normally electrolysis, but occasionally the other one.
Okay, and would that be the same for the FSRU? So that's for the existing refinery?
Yes, the FSRU would be exactly the same. They probably would have 2 electrolysis systems, so it's more reliable because chemical dosing on a boat's a bit hard to do, but that they would have exactly the same thing. For the FSRU calculations on the diffuser, we've assumed that their discharge of chlorine will be 50 microgram per litre, so maybe they're not quite as good as the refinery.
Yes.
And we've allowed a bit more.
Okay, thank you.
Okay, and I talked about underwater camera surveys. So this gives you an example of underwater camera surveys. These are near W1. So the coloured trace shows the track, and you can see there are little green dots on the track. There's a few dark green dots, and that is where there's a lot of seagrass. There's a few medium green dots, and that's where there's medium density seagrass. There's a few light green dots, or there's a lot of light green dots. That's where there's sparse seagrass. And there are white lines, and that's where there's no seagrass. So this is produced by our biological team. 2 biologists sit side by side. They look at the image, and one scores the density of seagrass. The other one scores the density of algae, the density of epiphytes, whether there's any sea urchins, whether there's sea stars, whether there's fish, and so on. So they do different tasks looking at the same image on a large screen. And that is then stored in a GIS system, so each image is geo-referenced to the position that was measured on the boat just above the camera at the time the image was taken. And so it all gets stored in a map which you can call up and look at and count and plot in various ways. So that's how it looks. And since I'm talking about sea urchins, when we did the survey 2 years ago, there were a lot of sea urchins around the refinery. And in the 2 years since then, they've all moved over to the Ramsar zone for reasons known only to sea urchins, I suppose. So we did actually think of testing sea urchins for chlorine byproducts, but then they moved to areas where there's no chlorine byproducts, so we didn't go ahead with that scheme. So that was mentioned in our study plan, but we didn't do it for obvious reasons. The request included a list of, well, what are the species of seagrass in Corio Bay? And there are either 3 or 5, depending on which biologist you consult with. But we've listed all 5, okay? So there's Nanozostra bulleri, that grows, it's a little short seagrass that grows in the intertidal zone and pushes out into the shallow water as far as it can until the taller Nigricorlis overshadows it and it's not getting enough light. So near shore you have a mixture of bulleri and Nigricorlis. Nigricorlis, it's not a single blade, it's a branched structure, well, like a gum tree, I suppose, but perhaps not as many branches. And it's got black stems. It's listed, I've got a threatened species here. Currently it's listed as an endangered species in the Flora and Fauna Guarantee Act. And Halophila is a paddle-shaped seagrass. It's quite short, but it has a big elliptical shaped leaf to capture as much light as it can, because it grows in the deeper water where there's a lot less light. And of course it's trying to grow into the shallow water where there's more light. And again, there's a competition between the Halophila and the Nigricorlis, and they are mixed together. So one of the things I seek to emphasise is seagrasses in Corio Bay are mixed together. You know, you can find patches of just Nigricorlis and patches of just Halophila, but they're constantly in competition with each other and constantly trying to move into the territory of the other. And they have each different ecological advantages and disadvantages that allows them to compete and find a space and try to move into the adjacent area. There are 2 others. There's Althenia and Rupio, which are sort of wiry kind of bushes. I'll show you a photograph in a moment, that grow in salt pans and on land and also in the sea. Some scientists say they're not seagrass, they're land plants that have moved into the sea, and some see it exactly the opposite way around. These are marine plants that have moved onto the land. And while we're looking at the list, I noticed that Dr. Edmonds has a slightly different nomenclature. He doesn't call it Heterozostra, he calls it Zostra, right? So we don't have a Heterozostra, but if you read our report, our biologist wrote a long history of how seagrasses are named and how the names change every 10 years. And I don't think the name's important so much as to know you've got Mulleri, Nigricorlis and Halophila as the 3 dominant seagrasses in Corio Bay, and a little bit of the other 2. Here is some Mulleri. Okay, it's intertidal, so this is low tide. You've been down there, I assume, and looked at the W4 outlet, which is a pipe, old pipe, going out to around mean sea level. And this Mulleri is covered by the plume. So at high tide, the plume just washes over this Mulleri every day, and Mulleri grows on both sides. So as far as you can see, it looks the same, according to our biologists. It's just as healthy, same colour, same size, as Millerai that's further along the coast that's not covered by the plume. So there's no great hole with no seagrass next to the discharges. Okay. Now, when you look at wastewater, which is discharging nutrients, the situation's entirely different. You do get a hole. But this has only got slightly warmer water and a low level of chlorine, and seagrass appears to be fairly tolerant of it. Here's Nigrocaulus. So you can see they're not sort of regular stems because they're branched, and there can be anywhere from 2 to 10 blades at the top of the plant. And the brown splotches, I suppose, they are brown algae that grows on the seagrass. Algae needs more light. Well, obviously it can't compete with seagrass, but it can float on the top and capture the light from the seagrass. And then on the stems, the epiphytes are the little plants and animals that grow on the stems of the seagrass. And some of them need a bit of light, some of them don't need any light, but they're certainly using the seagrass as a structure in which to make a home, effectively. And this is Halophila.
Just before you move on, if you go back to that slide, you said close to W1 outlets.
Yes.
Is that image taken within the plume?
Yes, that would be within the existing. It's quite close to W1. It's probably 50 metres off or 40 metres off. That Nigrocaulus grows quite well just near the W1 discharge, which is just a little bit deeper than the other discharges. It's that creek that comes out and the water's a bit deeper, so it doesn't really go through the Millerai area. It goes straight to Nigrocaulus, and you have these beds of Nigrocaulus. And when it gets a bit shallow next to the rock wall, you can get a little bit of Millerai manages to colonise it and compete. And then you've got brown algae there, which is also taking advantage of the situation. It appears to be more brown algae closer to shore. I suppose that makes sense because it needs a lot of light to grow, which is why it's growing on the top of the seagrass and only in the shallow water. And here's Halophila. Now you can see those are the paddle-shaped leaves. And our biologist pointed out a couple of days ago that the 2 or 3 blades on the right are actually very tiny Nigrocaulus, right? They're not Halophila. And that shows how difficult it is to make a map of each little patch of seagrass, because you have to have a little circle around these 2 plants and say, well, here we are, here's this microscopic circle of Nigrocaulus, and then next to it we have a bigger patch of Halophila. As I'll show later, Halophila is generally pretty sparse. It comes and goes quite a bit, fast growing, establishes itself, and then next year it's somewhere nearby. So it's quite variable and has a lot of holes. And these bushy patches, which look like they belong on land, are Althena rupea patches, and they're just a small patch in a Nigrocaulus meadow, and you can see another top left, another little patch of brown algae. So there's always a mixture of things out there in most photographs, but then some photographs, just at the right depth, you get a strip of pretty well all Nigrocaulus, right? It's too deep for Millerai and it's too shallow, or Halophila can't compete, right? So you get pretty much all Nigrocaulus. And so this is our map of observed seagrass. This is where the 3 species of seagrass can generally be found. that the dominant species in terms of cover are the three species I've explained, and you can see there's a zonation as it goes out. So we believe this map satisfies the condition of providing a map that shows where different species can be found and provides a basis for comparing the predictions of light availability from the model. You overlay it on this map and say, well, how does it look and who's affected and what happens? Now, the blue zone on the right, more or less, it's just inside the boundary of the Ramsar site. So most of the outer part of the Ramsar site is Nigrocaulus with scattered Althena. And then as you go further out, you get into the green hatch zone, which is Halophila shading off, which is Nigrocaulus shading off to Halophilo in the deeper waters. That's how it is. Now that's important. I'll come back to that and a little bit later in discussing with the panel what's our 20% mean and what's our 10% mean for the different species. We know the objective, it's how do we interpret it. The next slide.
Before we move on from that slide, Dr. Wallace, as I understand the critique that's advanced in respect of this aspect of your assessment, it was said, well, there could be a finer grain mapping exercise, if you like, more of a patchwork quilt if you're showing different species in different locations. Can you explain why it is you didn't adopt that approach?
Well,
and
yes.
What, having regard to the nature of the assessment that you're conducting?
Okay, we didn't adopt that approach because I think it might be impossible. You can make a map at a particular time, right? So we can make a map of seagrass species in Corio Bay as of May 2024. As of August 2024, we need a different map. As of December 2024, there's a third map. So it is changing quite a lot with time. And for example, if you look at that top right-hand corner, which is Point Abena, there's an example in the EES where you look at figures 565 and 566 in the EES. 565 and 566, it's the entrance to Limeburners Bay. And it starts with an image of November 2009 where there's only sparse seagrass there. By April 2011, which is 18 months later, there's medium to dense seagrass there. By June 2013, it's still the same. It hadn't changed over 2 years, medium to dense. But by September 2013, 3 months later, it's returned to sparse. So the idea of doing a map is okay if you want to do a map, probably of a smaller area, at a particular point in time. That can be done. But to do an environmental assessment, you need to know, well, where is seagrass generally or normally? Well, that's what we're trying to protect. And so for the Ramsar zone, we suggest, well, we propose or we say that this map here is a much better basis for making your assessment than worrying about little patches of this and that. And if we have some bare patches, you don't have to think, oh, well, do we not protect them? Or maybe there'll be seagrass there next year, so we would. So I think this map says, look, here's where seagrass is going to be sooner or later. And that's the kind of map that you need to make this assessment as to, well, what are the effects on seagrass in general over time? So I like the idea of a very detailed map. Haven't seen one yet. Now, I've talked about variability, and I just gave you an example of variability at a point which is documented in photographs in the EES so that you can see, you know, what really happens over 3 months, which is quite significant, and it helps you to understand that seagrass is quite mobile in responding to environmental variables, which are probably things that eat it. I think the seagrass over there is probably responsive to floods coming down Hobbles Creek, and so it gets a burst of turbidity and slows down. Fungal diseases are a key issue for seagrass, just like land plants, that seagrass is subject to fungal diseases and makes patches where there's less seagrass for a while, and then the fungi die out and then it comes back. So here, now these are from near map images, right? So they're just what's the area of seagrass. In that previous slide, there's 190 hectares, which are in the area where we say there's generally seagrass. And within that 190 hectares, what percentage of it is covered in seagrass in various years where we can get an image, a good image, between 2011 and 2023. And you can see that it goes up and down, right? It doesn't go up and down a lot. Seagrass in Corio Bay, like seagrass in Swan Bay, they're quite persistent. The good thing and the important thing, and I suspect one of the reasons for the Ramsar zone, apart from the migratory birds, is the seagrass in Corio Bay is there all the time. It's always there. But seagrass in Altona, for example, comes and goes. Seagrass on the Bellarine Peninsula comes and goes. Seagrass down at Mornington comes and goes. That this seagrass is always here, and that's important. So in summary, the seagrass here averages 64%, plus or minus 12%. So it's quite variable. That's the point of this diagram, is to show you that seagrass is variable. And here's another table to show you that seagrass is patchy, right? So we've taken all our towed underwater...
Dr. Wallace, I beg your pardon. If you go back to the previous slide, you had a note there in respect of port maintenance dredging occurring in 2014, 15 and 17.
That's because it's hidden by a pop-up, but now I see it. Yes, I wondered whether the variation might be related to dredging. So I looked at when did the port do major dredging, which is back in 2008, 2009. They dredged for a year. And then they've done maintenance dredging in 2014, 2015, but the seagrass in 2016 was a bit higher than before the dredging, and 2017, and the seagrass in 2020 is higher than 2016. I don't want to conclude that dredging increases seagrass. That's just casual correlation. We're not going to say that. But there has been dredging in the port regularly, and there is dredging proposed soon, sometime in the next year. And that is an important reason for having the baseline study, which either takes account of that dredging or doesn't. But the baseline study is in the year before the next lot of dredging for this project.
Do you mind if I just jump in with a question there? Did you have the data? Could you have done the bar charts for the years in which the dredging occurred? Like, I'm just noticing that there's no bars for 2014.
No, because you don't get a really good image very often, right? There's only a certain number of near map images, and you want one at low tide and with very good visibility without cloud cover. So these are all the ones we could get. We could have got lesser quality images in the other years, but we didn't, and I only thought of the port maintenance dredging after I'd finished this, and then I thought, I wonder if there's a relationship.
So can we infer anything from that graph about short-term impacts of seagrass, dredging on seagrass?
No, I don't think this graph tells you anything about short-term impacts of dredging on seagrass at all. No, I don't.
Okay, thank you.
So I want to just refer you to seagrass patchiness. And so we've got these 11,000 images of seagrass, and they've all been classed as bare, medium, dense. Sorry, bare seabed, no seagrass, sparse seagrass, medium seagrass, and dense seagrass. And so we can make the computer add it up and see, well, how much bare seabed is there? And in the area that's Halafilla, which is the offshore shallow area, there's a bit of Nigrocaulus, but basically 73% of the seabed is bare, so it's quite patchy out there, and it's quite mobile. The patches change from year to year. For the Nigrocaulus, it's more dense, right? And that's why it shows up better in the photograph. You can see most of it's medium to dense seagrass, but there's still 16% bare seabed. And because there's the variation from year to year and the patchiness, doing a very detailed map would be a monumental job. Could be done with lots of camera work and AI rather than people counting the stems and segregating it out. Could be done. I submit that if you had a map and it's coloured with thousands of little polygons, how will that help to make the decisions that you're going to make, as opposed to a map that shows here's where seagrass generally is, and therefore that's what we have to protect.
Dr. Edmonds was critical on my reading of his witness statement of this classification system that you adopted. He describes it as being a non-standard qualitative method. Can you explain, I think this is what he's referring to.
Yes.
In any event, can you explain why it is you chose this particular method?
Yes, this method was developed by the Victorian Government Marine Research Institute in about 2020. So the Victorian Government decided to make a survey of seagrass in coastal areas in Victoria, but they wanted to know more than just presence absence, which is what you get from looking at aerial images. They wanted to know, well, what's the gradation of seagrass? And they came up with this classification scheme, which is practical and you can do fairly quickly. So their definitions, and these are the papers by Blake and Ball, there's a whole series of them because they worked away for years. Sparse seagrass is where plants are present, but the leaves do not touch each other. Medium seagrass is where the meadow is thick enough for the leaves to touch, but you can still see sediment, between groups of plants. Dense seagrass is where there's thick growth and it hides the sediment underneath from view. And so that's a recognised classification system in Port Phillip Bay for this, Port Phillip Bay, Western Port Bay, whatever that inlet is next to Wilson's Promontory. So this is the definition that's been used in seagrass surveys next to in Victoria, and we've continued to use it. And it's been used on numerous studies, St Kilda Harbour and Blairgowrie and St Leonard's by Parks Victoria. They must have done 10 studies using this classification scheme. So it's the normal classification scheme used in Port Phillip Bay. Now, the criticism that you can make is medium covers a rather large range. It covers anywhere from 20 to 80% seagrass. That's medium. So we thought about that and we said, well, why don't we divide that up into two? We'll do 20 to 50 and 50 to 80 and see if that makes any difference. And we did that for 2 days, and then I added them up, and they gave me the same result within less than 1% when I added them all up. So I thought, no, the extra effort is not worth it. That I have to have people staring at the screen for longer, and I don't get any extra information in terms of total percentage seagrass cover. So the way we use the classification is we multiply sparse seagrass by 10%. We say sparse seagrass is 10% of the cover. Medium seagrass is 50%. Dense seagrass, 95% cover. You can experiment with changing 95 to 90 and changing 50 to 55 or 45. And you can see that it doesn't really change it very much. The definitions work out pretty well in terms of telling you there's 70% seagrass offshore, subtidal, and there's a little under 30% seagrass intertidal, right? Which is the numbers that you need to think about. You know, about a third of the intertidal area is covered with seagrass, and 70% of the subtidal areas are covered with seagrass. So that in your 190 hectares, there's 120 hectares of seagrass on average, plus or minus 15% from year to year. So that's what you're protecting, and it's a very important asset in Corio Bay. And in summary, Mr. Chessel, I think it's a very fine classification scheme because it's practical, robust, used by many people for many years, and if you change to another scheme, you'd have to do an intercomparison and show how they worked, and then we have to adjust the past results. And I don't think we'd find the numbers are very different. You know, instead of 70% seagrass, you might find it 67% or 73%. The number is different, but your interpretation of the number is not that different. You know, it's somewhere between 2/3 and 3/4 seagrass. That's the fact that you need to absorb from this.
Okay, thank you.
So that completes my presentation on 1A and 1B.
So if I can, occasionally ask a question as you go through these recommendations, just to seek clarification while it's still hot, sort of, so to speak. So understand that we're now at slide 14, but can I get you to go back to slide 3, just for a moment? Just got 2 quick questions.
This one here?
Yep.
Yep.
So again, in analysing what the Minister's direction says, the question is, in your opinion, does the existing environment contain habitats other than seagrass, which we've just spent a lot of time talking about?
Yes.
So does the existing environment contain habitats other than seagrass that are impacted by the existing wastewater discharges?
My opinion is yes and yes, but I qualify that by saying that the big component, the fundamental component of the habitat is seagrass. And if you think of components like epiphytes, swans, sea urchins, they depend on seagrass. You won't have epiphytes if you don't have seagrass. So yes, there are a number of other habitats there. Many of them are dependent on fish, for example, breed in seagrass, so they need the seagrass. There are some other habitats which are independent of seagrass, salt marsh, nearshore algae, small fauna that live in the sediments. I'll discuss a couple of those later. In our assessment, we made a screening assessment, which is reported in the EES, of all these groups, and we said they are either less sensitive to these stresses than seagrass. So if you're intertidal algae and you're in the sunshine every low tide, you are probably not light limited like seagrass, subtidal seagrass, which is always in the water and therefore much more affected by extra turbidity. So the answer is yes, there are other habitats, but in our assessment, there's not another habitat that is more sensitive and more important than seagrass.
And just a bit for completeness, in relation to those other environments that you just mentioned, was any further survey work undertaken on those elements to better establish existing conditions?
We did do further survey work on fish, sea urchins. I've got a slide later of intertidal algae, but we did not do further work on mangroves, for example. Salt marsh, because it's on land. We didn't do further work on animals that exist under sea wrack, for example, because we do not consider there will be more or less sea wrack as a result of the project. Therefore, those animals are there. They're a different environment. They are related to seagrass, and they're not significantly impacted by the project. So our view is you only look at the elements of the ecosystem that are significantly impacted by the project. So they have to be more sensitive than seagrass to dredging.
Thank you, Doctor. Back to slide 14.
Okay. I actually have a list here, which may help, just to round out the question, that our risk assessment considered benthic filter feeders, and there's a list of them, small fish, sea urchins, detritus feeders, introduced pests, shell rubble with Homocera algae, migratory waders, salt marsh, mangroves, iconic species, because everyone's interested in what happens to dolphins and penguins and whales, aquaculture, filamentous algae, water birds, shrimps and sea stars. So we did do a scanning risk assessment of all those components of the ecosystem and made the decision with the criteria I've expressed.
The list that you just read out, can you provide a reference for us?
Table 4.3 of the EES.
EES or SEES?
EES. The scanning risk assessment was done in the EES.
Is that the technical report or the chapter?
It's chapter 4 of the EES.
Okay, thank you.
So we haven't neglected other components of the ecosystem, but we've made a judgment about what to focus on.
Thank you. Back to slide 14, I think.
Slide 14.
Thank you, Mr. Chessel.
This is the one, isn't it? We're on to the next recommendation. And so the parts C and D were to have a baseline survey that's carried out over a period of at least 12 months before construction or dredging with seasonal runs, and establish a better baseline for monitoring during and after the project to confirm the predicted outcomes on shoreline and benthic communities, including seagrasses and macroalgae. So we interpret this as a 12-month study before dredging that goes straight into a 2-month study during dredging, where there's thresholds set that the dredging contractor has to adjust dredging to ensure you meet the thresholds and you don't cause impacts. And there's a 12-month study after dredging. So the whole thing's 26 months, and you set up and monitor for 26 months. That's what was agreed with the TRG. We've set out the program in the SWS. It's been reviewed by Stantec and the TRG. Some adjustments have been made in results to suggestions by the EPA and Stantec and others during the TRG, and that's the baseline that is ready to go when people know when dredging occurs. And it's important that the baseline is conducted in the 12 months before dredging, because there might be port dredging, or there might be major floods in Hovels Creek, there will be development of the Hovels Creek catchment, so things will change perhaps a little or perhaps significantly over the next 2 or 3 years as that all that building starts. So you've got to have the right baseline, which is collected just before you start, and we've set out what that study is. Part of that study will be to define or refine thresholds. So we've suggested thresholds which we think are appropriate now, and I'll show you in a later slide. But once you've done 12 months of detailed monitoring, then there's a marine report that's prepared as part of the planning application, and that would have revised thresholds. The thresholds are then agreed as part of the Marine and Coastal Act approval. That's where they're finally set. So we suggest thresholds now based on what we know, and in the end there is a process to refine and finalise those thresholds. Well, this really just repeats what I explained before, that when we look at the environmental components to study, we look at the stresses and we look within the area of the DGV for those stresses, right? So we have defined our temperature envelope for a 3-degree change, and 2 degrees is well short of Ramsar, and we look at species and components of the ecosystem that exist within that footprint, right? That you don't work out the footprint and say, but I'll go and study at Altona anyway because it's convenient. That you have to study within the footprint. And we look for a potential for a significant effect, and noting that CBPs extend beyond the footprint. So, we look more broadly for them. And dredging stresses are turbidity and light reduction and sedimentation, which are assessed separately. Now, Dr. Edmonds put up a diagram, and I've just shuffled his diagram to show you how seagrass is fundamental to the whole ecosystem in Corio Bay, right? So the seagrass macroalgae sits on top of the seagrass and actually is competing with the seagrass for light. So you can see this little ellipse there showing shading, and that affects seagrass. But seagrass provides shelter, and it's that shelter that protects fish. So that's where they breed. It protects them from predators. So you get idioplankton, which are the fish eggs, which grow into small fish, which grow into large fish. So you don't have the fish without the seagrass. If it was all a muddy bottom, it would be completely different. The seagrass produces wrack on the beach every year in summer. We're all familiar with it, and that's generated by storms as the seagrass matures. And that wrack provides nutrients for a whole lot of animals that live in the sand under that beach. And that goes on to consumers and predators, right? Birds come and feed on the animals that are consuming the wrack. So we say seagrass is very important. Previously in the EES we studied phytoplankton, and we think there's enough given there to know about phytoplankton. And there's a whole series on the right which are mangroves, not studied because they're outside the footprint, not really sensitive to changes in light or turbidity, so not really going to be significantly impacted. Salt marsh, it's on land, not going to be significantly impacted. Rock algae, I'll show you a slide in a second. MPB is Microphotobenthos. That lives on the muddy seabed, obviously will be affected. And we've said that in the EES, and there's nothing more to add. If you live in the area that's going to be dredged, you're going to be dredged. And the area around will be significantly impacted because there's a lot of sedimentation close to the dredging, and all that MPB will recover in a year. But that's been stated in the EES. There's nothing more to add because there's nothing different. Critical component of the ecosystem is the 20,000 species that live in the seabed, and they provide the nutrient cycling that enables the seagrass to exist. We don't know a lot about that, but we believe that it continues during dredging. It's not significantly impacted because it doesn't depend on light. And if it gets a bit of extra sediment, that doesn't make any difference. It just adjusts to it. So it's not, when you do a risk assessment, going to be significantly impacted. Therefore, you don't have to do a study of that to assess the impacts of the proposal. Now, mentioned intertidal algae, and quite a lot of these things we documented in our internal memos. So the bottom right figure, probably a bit hard to see, but shows a series of little boxes where you can find intertidal algae in Corio Bay. And here's an image of 5 of them. And they're quite spread out. So where you have some rock on the shoreline, it grows intertidal algae. And we have not included impacts on intertidal algae because, in our view, intertidal algae will have plenty of light at low tide. It's the seagrass that is very dependent on having light over particular periods, and therefore intertidal algae are less sensitive than seagrass. You could say their impacts are represented by seagrass. If the seagrass is still there, the intertidal algae will be still there.
It's time for our morning break, but could I just ask you a question before we break about the 12 months of background of monitoring before you start the dredge campaign, that baseline monitoring? Is the purpose of that would that be used to inform the dredging program? So, for example, you mentioned there might be storms, you might get a lot of turbidity coming out of discharges from Hoddles Creek, etc. Would that information be used to inform when you would start the dredging program, or is it purely to measure the effects of the dredging program?
No, I think it would inform when you do the dredging because if you have high turbidity already, then clearly adding more turbidity is not appropriate. If the port has a planned dredging program, then you can't have two running together. And the major influence is on the contractor, right? The environmental standards are set. Seagrass must have 20% light over some agreed averaging period. And so it's the contractor has to adjust their program to meet that. That's a requirement, right? It's a requirement exactly like you must remove 490,000 cubic metres of sediment and put it over here. And so the dredging program itself would change based on the results of that study. And you would see how difficult it is to meet the target, or it might be easy to meet the target, and adjust the program accordingly. So it would have quite a big influence on what's done.
And are you satisfied that that's built into the mitigation measures that are before us?
Yes, it is one of the mitigation measures. That's I believe.
But that light threshold effectively requires the programming of the dredging to have regard to background conditions.
Let me consult with Mr. Chessel over the break, and I'll give you the other answer to that question.
Okay.
But my understanding is that 12-month baseline program is a requirement.
Yes.
And it's not really a mitigation measure, it's a requirement of, you must have the monitoring equipment in place and operating during the dredging. You must have had it in place and operating before the dredging, and establish what are the baseline conditions and what the thresholds are that are appropriate to those baseline conditions. And you must have it in place for the 12 months after dredging to show that conditions afterwards are the same as conditions before, subject to the normal variability of seagrass.
Okay. You're not allowed to talk to Mr. Chessel over the break.
I didn't know that. Yeah.
Well, he's not technically under cross-examination yet, but I'm happy not to talk to the witness.
Yeah, I think we might just keep it cleaner.
That's
and
quite okay. Yeah.
You can come back to us on
of course.
in submissions if you feel the need to, if you think that's significant.
That's absolutely fine.
We'll break until 11:35.
Thank you.
Okay. I am just a little bit mindful of the time. We've been going for over an hour and we're only about a quarter to a third of the way through the slides. So appreciate there's a lot of detail in there, but we might just need to start moving through them a little bit more quickly if we're going to get through everything we need to get through in the next 3 days.
Yes, thank you. To that end, I thought that the next 6 slides all cover the same topic, which is the impacts of existing discharges on seagrass cover and the comparative exercise that was undertaken comparing seagrass cover within the plumes to seagrass cover within the Ramsar sites selected randomly. I thought that there might be an opportunity to address those slides relatively expeditiously. If you're happy with that approach, Member Kolar, what I thought I'd do is invite Dr. Wallace to, perhaps by reference to the second of those slides, the one that has the Transex surveyed at multiple sites. If you could just explain what it is you did, why you did it, and the nature of the statistical analysis that you undertook to compare the 2 sites.
Okay. This is, what are the impacts of the existing discharge? Sorry.
Yep.
What are the impacts of the existing discharges? And in this case, we're looking on seagrass. And we did that by measuring seagrass using the technique of seagrass cover, using the technique I've outlined. And we had 4 transects in the area of the temperature footprint, right? So we know these are in the plume regularly, not all the time, but regularly. And then we took 4 transects at 2 other sites over in the Ramsar site, and they were selected randomly, which you need to do to have a proper comparison. And then we measured seagrass cover at multiple sites in each of those. We did a power analysis that said, well, to detect 10 to 12% change, we'd need 3 surveys. So we did 3 surveys. They weren't done to measure the seasonal change in seagrass. They were simply 3 surveys that we separated by time and by when low tide was available during the day, which is a major constraint because it only occurs every few weeks. So I don't need to go through that. That's really what we've done. And then we aggregated all the results and said, all right, we've got 400 sites that have been sampled in the plume, and we've got 400 sites that have been sampled over in Ramsar. Is there a difference or not? That's one. Is that difference significant in a statistical way? And I'd like to talk about this diagram, but it takes a while, so I'll be happy to answer questions on it. And this is the results. So the graph on the left-hand side shows the average with the error bar for the West Shore location. This is the seagrass cover in the plume, which is a bit over 70%. And on the right-hand side is the seagrass cover in the Ramsar sites, 70%, plus or minus a few percent. And in our view, they're the same. And we did a statistical test that showed they're the same, but I'll come back to that. On the right-hand side, intertidal seagrass is more sparse. There's less cover, right? But again, when you compare the average cover in the plume footprint sites to the average cover in the Ramsar sites, they're the same. So during the period of our surveys, there was not an observable impact of the existing discharges on seagrass cover. And from that you can infer, or anything that depends on seagrass cover.
Why did you choose seagrass cover as the relevant metric?
We chose seagrass cover because you don't want to do fish because they swim backwards and forwards. They're not really always in the plume. We did intertidal seagrass and seagrass because they're fixed in sight. There's not many other indicators that you can use that, for example, if you try and say in-fauna in the beach turn over very rapidly from month to month, and so very hard to find a stable population. So seagrass are a resilient, stable population that you would think if there was an impact, it would show up in the seagrass. And if there was an impact on seagrass, that would be significant for the ecosystem of Corio Bay.
Now, Dr. Wallace, before you move off that slide, and there are a couple of things that have been said about your analysis. The first is that the statistical approach that you adopted isn't appropriate for the purposes of the type of comparison that you're seeking to make. What do you say in response to that?
What do I say in response to that? That the standard test to compare the mean of two distributions is the t-test, and that's the test we used. And we used a two-sided t-test because it could be bigger or smaller, so we looked at both sides. And I've been amazed at the number of opinions that we've got back about statistics. So I went to consult a professor of biological statistics to say, well, you know, what does he think about these opinions? And he said...
Who was that person?
Professor Keogh.
Thank you.
He said, well, I don't agree with them, but here's 3 other ways to do it. So we took his 3 other ways, and they also showed there was no significant difference. So I think we're agreed that there's not a significant difference, but we are not agreed as to which is the appropriate statistical test to prove that.
What I'll call a second Stantec peer review raised an issue in respect of the potential for something described as pseudo-replication, as I understand it.
Yep.
Can you explain what that means?
Pseudo-replication means all the sites are collected from the same area. So if you're comparing a horse with disease with another horse that hasn't got disease and you collect 40 samples from each horse, there's pseudo-replication because really you're just sampling the same thing over and over again. And therefore, if you look at our sites on Ramsar, in our view, they are spread over a large area. In the view of Professor Keogh, they're spread over a large area and are not all the one site. In the view of Stantec, they are all from exactly the same site. It's a matter of your definition as to what is a site. So simply, we don't agree.
Yep. Just as a point of clarification, how did you define the site? Is the site a transect or a site a subset of a transect?
Yes. So we have locations. So there are 2 locations, the plume footprint location and the Ramsar location. And then we have transects that are at various fixed depths. So we're trying to avoid a confounding effect of depth, so we select the same depths at each location. And then we have sites which are points at 15-metre intervals along each transect. So there's typically 30 to 40 sites on a transect, and each site is 2 square metres by 2 square metres, which is the area in which you assess seagrass cover as being none, which occurred a few times, sparse, medium or dense. So in terms of sites, there's about 400.
And so was your t-test then carried out using the 400 sites?
Yeah, 400 here and 400 there. That's the t-test.
And did you then assume the sites were independent of each other? Could you assume the sites were independent of each other?
I'm assuming the sites are independent of each other in the sense that one group of sites are in the plume and the other group of sites are very obviously not in the plume, and that's what I'm testing.
Yeah. Now I'm asking about the 400 sites. Are they independent of each other?
I think they're independent of each other because they're scattered along almost a kilometre of coastline.
Mm-hmm.
Okay, thank you. I'll invite you, unless there's anything else you wanted to say about that topic, I'd invite you to turn to the slide that summarises the baseline study prior to dredging.
The baseline study by the dredging. So we've set out a baseline study for dredging, and this will provide the information on which to define the thresholds, or refine the thresholds, since we'll define the thresholds, but they'll be refined as a result of this work, and set out all the monitoring equipment which is used during the dredging program. Okay, so you can see there's the dredging areas in red, there's some seagrass tows to look at seagrass cover, there's some sampling of seagrass length to see if the cover's the same but the seagrass is shorter or longer. There's some chlorophyll sampling to see if algae, there's an algal bloom as a result of sediment releasing stored nitrogen. There's light monitoring at a series of sites along the edge of the Ramsar site. There's turbidity monitoring at a series of sites, and there's in-fauna sampling closer to the dredging to see if sedimentation has an impact. So that's the plan, and there is a schedule of activities.
Now, you were asked a question before the break concerning the extent to which the statutory controls would give effect to a monitoring program. My question to you is a broader one. Is it your view, or to what extent is it your view, that the relevant requirement to undertake a baseline study should give effect to the parameters of the study as specified within your work?
Yes, it's my view that you do need a baseline study of this type before you start dredging. That because of the variations in conditions, it's appropriate and best to put it just before you dredge, because that's providing a proper baseline. If we'd have done 12 months, we would have finished last June. And then there's another long gap where things will change and who knows what will happen. So you do need to target the period before dredging, and that gives you all the equipment in place for dredging. So it's the same equipment that continues. It's the monitoring of the light and the NTU at the edge of the Ramsar site that provides the data to protect the Ramsar site. And the response is you don't change the threshold, the contractor changes what he's doing, right? It's the contractor who's impacted by the results of the monitoring program. I mean, effectively, they have to alter or slow down if conditions get too high for any reason, not just due to dredging, but due to other effects which would be stressing seagrass at that time. Don't add to it. That's really the point of the adaptive management program. Some quick responses. Maybe this will come out in cross-examination. So there were some things that were agreed, and there were some things that were not disagreed, which includes the statistical test. But that's the results of the conclave, and perhaps interest of time, we won't go through them.
Can I just ask you to comment on one of those? And the first of the matters that you've identified as not being agreed is disagreement as to whether you should have examined more ecological units, areas of rock platforms and gravel beaches in the intertidal area and subtidal zone should be mapped. This is a disagreement between you and Dr. Edmonds, is that right?
That's correct, yes.
And I know you've touched on this already to some degree, but can you explain why it is you consider the analysis that you conducted to be adequate for the purposes of informing this assessment?
Yes, it is our view that seagrass is more sensitive and more important than these other areas. In other words, the turbidity will affect seagrass before it will affect intertidal algae. And gravel beaches, or the animals that live in gravel beaches, and the animals or the birds that feed on animals that live in gravel beaches, which are in the intertidal area, will barely be affected by seagrass, but by dredging. And the change in seagrass cover, which produces towards the end of the growth period, some seagrass dies off, and that gets washed ashore in storms. That will continue. That isn't altered by the dredging. That's really the major factor, is the storm activity. So therefore, we have examined what we consider are the most important ecological units and the most sensitive ecological units to the stresses, which are turbidity and light.
Thank you. We move to the next slide, please.
Okay, recommendation 2, I don't need to talk about this very much. Refine the calibration of the model. It's all been done. All these tasks were done.
And these tasks, where were these tasks specified?
They were tasks specified in recommendation 2, and so we had to select the appropriate wind data, change the grid spacing, and put the FSAU in the model to see what effect it had on currents. And I assume the wind data was discussed at length yesterday, and I would only like to point out one fact. If you look at the median current speed, which is the 50 percentile, and the dashed green line, you can see it's only 0.04, right? It's a very weak current speed. And when you look at the current records, you see there's a lot of variation in the current speed from minute to minute. And that's because it's an acoustic current meter that's bouncing a signal off small particles of debris, which are in the water column. Therefore, the accuracy of the measurements is only plus or minus 0.01. Right? Therefore, when you compare the model with the measurements, you can say, oh, well, they're not exactly the same. Some of those might be due to the model being not quite right. Some of them are due to the measurements having a lot of natural variation. So you would never expect with a weak current to get a perfect correlation. If the current speed was an average of 0.2 metres per second, you'd expect to get an excellent correlation. But because it's so weak, that makes it hard to get a correlation. And I just want to point out, because it was the request of the IAC last time to look at the wind file, because there was a suggestion that we should be using the Avalon wind file, and we've been using the Geelong wind file. And now we're using the Calamont wind file, which is in between. What difference does that make, right? You know, if we've done a search for the best wind file, what difference does it make? And so you can see that black line, which is oblique, which more or less picks up the end of the temperature plume. So with the Geelong wind file, which are weaker winds, you get a longer plume because there's less mixing. With the Calamont winds, which are slightly stronger, you get a slightly shorter plume. And with the Avalon winds, which are even stronger, then you get an even shorter plume. So the effect of changing the wind file means that the plume's got a bit shorter than it was in the EES, and actually the mean turbidity has gone down a little bit because you've added a little bit more mixing. It's not a big effect, but changing the wind file has had some implications, small implications. Okay, we now match the tide height profile and the current speed profile. I just want to make one comment about current direction. Right? A lot of the currents at the current meter site are approximately north and approximately south. And when you have an approximately north current that's plotted on a scale of 0 degrees to 360 degrees, and you think, well, you measure north less 5 degrees, that plots as 355, and that's at the top of the graph. And your model says, no, it's north plus 5 degrees, that's 5 degrees. That plots at the bottom of the graph. So when you have those graphs of current direction that go from 0 to 360, you seem to see a great discrepancy, when in reality there isn't one.
Just on that point, Dr. Wallace, what I'd like to do is invite Mr. Chow to share the screen, and I'd like you to address this topic in light of an issue that was raised yesterday in the context of the hydronumerics report.
Okay.
And we'll turn in particular, please, to page 57. Let me just get the right. Yeah, just bear with me a moment. Okay, it's document 14. And to PDF page 57.
Is Mr. Chale popping that on the screen?
Sorry, yep. I gave Mr. Chale the wrong document number.
Does Dr. Wallace need to stop
Unshare, that's what I was
sharing?
wondering.
Yeah.
I think you can usually just steal it away. I think we can do that.
So is this the hydrodynamics 2020 November report?
Yes.
It's not the early one.
Yes, thank you. This is the image that was referred to yesterday.
Okay.
And Dr. Wallace, is this the type of
yes, you can
plot you're referring to?
That's what I'm referring to. You can see that, take the lower image 2/3 of the way across. There are a whole lot of little red lines up near the top of the graph.
Yes.
And there are blue lines that extend to the bottom of the graph. So it looks like there's a big difference, right? But in fact, the difference is only a few degrees.
Why is that?
And that's because you've gone through north. So if you go through north is 360 at the top of the page. If you go just a bit beyond north, you're down at the bottom of the page. And if you're a bit before north, you're at the top of the page. So this kind of diagram visually exaggerates the difference between the readings. It looks a big difference, but it isn't really. It's the way it's plotted. If you added 90 degrees to every number, they plot a lot better.
And so if we return, that question was put to another witness in the context of a statement that was contained within the Technical Report A, and that statement's at page 197 of Technical Report A, and I'll read it to you in the interest of time. As an example, a time series comparison of measured and modelled currents is provided in figure 4-8. The refined model reproduces the measured current speeds and direction from the winter 2021 ADCP deployment to a satisfactory degree, why is it you form the view that the refined model reproduces the measured current speeds to a satisfactory degree?
Because when I plot a frequency distribution of the measured currents and the modelled currents, they match fairly well to a reasonable degree. Therefore, in my view, they match to a reasonable degree.
Okay, thank you.
Okay, the last one was the effect of the FSAU on currents. Now, the FSAU is...
Yes, sorry, Dr. Wallace, can you please share your screen again and be in control of the presentation?
Sorry. Great, thank you. So just point 2D quickly. This is the effect of the FSAU on currents. So the diffuser has a lot. Roughly every 2 metres, it's got a small port discharging at 5 metres per second. So you get a whole lot of mixing in the first 15 metres. FSAU is 50 metres away, so that jet mixes long before it gets to the FSAU. The mixing under the FSAU is nothing, right? Because you've made such a large diluted field that it's quite slow to keep diluting. But if you think the discharge from the FSAU has got 50 microgram per litre of chlorine, we divide by the dilution of 20 to 1, it's down to 2.5. So I think we say here, so we say it's 3 microgram per litre, right? This is the 3 microgram per litre contour. All of that is unaltered by whether or not you have the FSAU in there, because no dilution occurs under the FSAU. The temperature coming out is variable, but let's say it's -7 degrees. -7 divided by 20 is whatever it is, -0.35. So again, you're reducing the temperature down to about 0.4 degrees, whether or not, before you get to the FSAU. So the FSAU effectively has no influence on currents. All the solutions with the diffuser are created by the jets coming out of the diffuser, and there's practically nothing from ambient turbulence. And all of that are model predictions, but they're not regional model predictions. There's a separate model for the jet dilution. And you'll notice in the report, we engaged an independent expert in Hong Kong to check our calculations, because there was a question raised at the last session. And he got, somewhat surprisingly, the same result as we did. I mean, the exact same result. I expected it to be a bit different, but he got the same number, which is 20 to 1, as we did. So it's quite well verified as to what the dilution will be from the diffuser, and the resulting chlorine and temperature will be well within the DGV. Okay, I believe the model is fit for purpose for a number of reasons which are there. I won't go through them one by one. I will say that Stantec's first review said the regional hydrodynamic model calibration is sound, and the model reflects observed current and tide data. So at one point we were all in agreement that the model was satisfactory and fit for purpose. I won't go through the comments on the model. You've probably heard enough about that, but if you want to ask me, I'm happy to add my responses.
There are just a couple of things that I think we could usefully address at this point. The critique of the hydrodynamic model doesn't concern, as I understand it, any of the aspects that were the subject of the IAC's direction. Instead, the critique of the hydrodynamic model concerns its treatment of the extent to which wave effects induce resuspension of particles as a consequence of impact on the seabed.
Okay.
Can you explain to what extent that was taken into account and whether you consider that to be acceptable?
Yeah. The model that was produced by Hydronumerics included a wave prediction component. It was not a sophisticated SWAN model, but a simpler wave prediction component, which I considered was appropriate for Corio Bay because the waves very rarely get above 0.3 metres, right? That's a pretty small wave. So it is a place with very small waves, just like Swan Bay. And the reason both Swan Bay and Corio Bay have a lot of persistent seagrass is because they're small bays with small waves, right? So you know that from the size of the bay, it must have small waves. Therefore, waves are not a big process. Where the high shear occurs is near the edge of the bays. And if you think back to that map of seagrass, the high shear occurs where there is seagrass. So you're not getting a lot of resuspension of sediment in an area that's covered with seagrass. So therefore, we concluded that resuspension is not a significant matter except when there are major storms. When there are major storms, the whole of Corio Bay becomes turbid. It resuspends from the bottom in the muddy section and spreads it around the whole of Corio Bay. And when I show you the figure of predicted sediment concentrations from the dredging, when there are high values, there is high background, right? There's high sediments normally from resuspension. So everything will occur together and you will have 6 to 12 hours of very low light due to a combination of natural resuspension and dredging resuspension, right? But in effect, this natural light is very low naturally, so it doesn't change things. Therefore, it's not important to model it to more than a coarse degree. An approximation is quite satisfactory for modelling the waves and the resuspension in Corio Bay. I would say something quite different if we were in Bass Strait, where it would be very important.
Okay, 2 other questions on this topic. Dr. Edmonds, in his report, says in respect of this recommendation that there's a knowledge gap, and that knowledge gap is said to be knowledge in respect of the tidal exchange with Limeburners Bay. What do you say in response to that contention?
Well, there's no knowledge gap. We know exactly what the tidal exchange in and out of Limeburners Bay, because Limeburners Bay is in the model, and there's 20-metre square cells at the entrance of Limeburners Bay. So it's not a knowledge gap, that's actually known. But you'll notice that the temperature plume doesn't go to Limeburners Bay, or it doesn't go, the footprint is well short of Limeburners Bay, so therefore it's not relevant how much goes into Limeburners Bay. The turbidity is at quite low levels. That's quite shallow in Limeburners Bay. It is the seagrass at the outer edge of Ramsar that is the most sensitive to reduced light, right? Because there's 2 metres of water there, and you've got reduced turbidity and higher light attenuation over 2 metres. If you go into shallow areas where it's only 1 metre deep, the reduction in light is much smaller. So it's the outer edge of Ramsar that is the critical place for assessing the reduction in light attenuation.
Thank you. Now, the final matter is a matter that's recorded within the conclave statement that you participated in with the modelling experts. And in respect of recommendation 2, one of the agreed things was this, that additional information needs to be provided of, I think it should be, the parameterisation of fetch, the basis of the choice of the KT value, and further explanation of wave bottom stress calculation. I'll ask you this question. What did you mean when you agreed to that, and what additional information, if any, needs to be provided in the context of this process?
I think that was additional information to be provided by Dr. Yates, and I would have thought it had been provided in his presentation. Sorry, okay. I was not able to listen to it yesterday, but I would have thought that would have been discussed. And
okay. Thank you.
So it has been provided, as far as I know.
For the benefit of the committee, I know that there are a number of similar questions about similar statements in respect of other recommendations. and we'll come to those in due course. I thought I'd just pick up the recommendation 2.1 as we move through. Okay. Can you please turn to recommendation 3?
Yes, recommendation 3 was to effectively run the diffuser case. I've already shown you an image showing what the predictions are for the diffuser case. And there's general agreement that we've done that and there is no change in findings.
Okay, what I'd like to do in respect of this topic is, if we turn to technical report A, there were a series of questions yesterday as to how one should interpret various plots or various figures contained within the technical report. And some of those relate to recommendation 3, some relate to other recommendations, but I wanted to undertake that exercise now if we could. The first image is first figure is at page 103, that's PDF page 103, of the technical report. If you have the hard copy, that's at page 5-88.
5-88. Yes, 5-88, yes.
And the question, as I understand it, is whether this figure represents a mean representation of the relevant envelope, a point in time representation, a worst case representation. Could you please describe what this shows?
Okay,
and why it was selected?
This prediction is a combination of 2 models. The first is the jet model, where the flow comes down from the diffuser and continues along for about 15 metres. That produces the dilution of 20:1. That flow and concentration and temperature are put into the regional hydrodynamic model to see what extra dilution they are, and it's a bit, right? So I showed you a previous figure which had a contour of about 0.3 degrees or 0.4 degrees, I think. And you get a bit of extra mixing as you go the extra 500 metres, right? And that's what shows up in the regional model. It's a mean figure, but keep in mind that the major process is the jet dilution, which is relatively constant, right? You generally get 20:1. That does vary a little bit with tidal currents, but not much, right? It might vary from 19 to 21:1, but it's something that happens all the time because the reason it happens is the high momentum of the jet, right? Which is not an environmental thing, that's fixed. The extra bit varies depending on the tidal currents and the wind-driven currents in the regional model, and that's a small component. So this is a mean figure, or average figure. How much it would vary? It would vary a little bit, but that doesn't matter, right? Because the limit for temperature is 3 degrees, and this is 0.2. So whether it's 0.2 or 0.3, does it meet the DGV or not, right? And even if I use the terminology that I read about in Dr. Gard's report, even in the worst case, it's going to meet the DGV for temperature and chlorine by a large margin. So.
All right, let's do the next one, 104.
104.
Over the page. Is this
so the first one was
chlorine?
temperature. That's the same thing. That's the chlorine one.
So that's a mean representation.
It's a mean representation, but again, the change is quite small. It's a few percent, plus or minus 5%, which on 3, it's going to go from 2 to 4.
And that's a combination of near field and.
That's again a combination of near field and far field, but the near field is fixed and the far field is variable.
Yes.
But the near field is large and the far field is small.
Over the page 105.
Figure 5.5. Figure 5.5, this is the temperature envelope I spoke about. So we did 6 measurements of the extent of the plume. We then, and in each case, we did the 1,000 measurements of temperature and predicted the plume, and somewhere there's a plot of the 6 plumes, and somewhere also there's a plot of the 6 predicted plumes. This figure 5.5, is based on measurements, right? What we did was get the GIS system to pick out the highest concentration at each cell, each 20 by 20 metre cell and then contoured them, right? So these are GIS contours of measured temperatures, nothing to do with a model, right? These are just measurements. And again, I emphasise that at any time, the temperature plume is 30 to 40% of this envelope, right? This is where does the plume touch, not what's the plume look like for any particular plume, because it's a lot smaller.
Okay, thank you. The next page was a question about the next two images.
There's a figure 5.6 and figure 5.7.
Yes.
Yeah, they are calculated from the previous figure, right, with a particular drop in temperature. So I'll have to quickly read the text. So we're saying that if we drop the discharge by 40% in summer, 7 4s are 28, it's like 3 degrees. So instead of coming out at plus 10 degrees, it comes out at plus 6, right? That's what happens in summer. Then that temperature envelope becomes a lot smaller. That's just effectively taking different contours in that measured envelope and saying, well, if everything was 4 degrees smaller, what would the 3 degree contour look like and what would the 2 degree contour look like? And the lower figure 5.7 is applying the same thing but saying, no, this is in winter, the FSAU is discharging at -7 degrees, the refinery's +3. Here's what would happen, right? And those temperature plumes become very small, right? Because it's only coming out at +3, and it's only W1 actually that has a +3 contour. It's very tiny. It's just before it dilutes a bit to less than 3.
And again, just so we're clear, to what extent are these images composite images that reflect extensive plumes as opposed to point-in-time representations of a plume?
They are all predictions of envelopes, right? So they are based on the envelope of the 6 experiments and reducing the size of the envelope for a reduction in source temperature. They're nothing to do with the regional model.
Can I just ask a question of clarification there? So are you saying that for your maximum temperatures that you've measured and that you've done the contours on, you've simply subtracted a constant value across the whole surface for each one?
Exactly right, yes.
And so what was that value? You said 3 degrees?
Well, it says 40%. So if we say it's coming out at 10, then in summer it's going down to 6, right?
Yeah.
And then in winter, on page 590 it says 90, so therefore, yeah, you're taking the whole of the -7 degrees. So instead of coming out at 10, it's coming out at +3. That's really the difference.
But you haven't then calculated out how that spreads, you just subtracted that from...
Well, that's going to spread exactly as it would have spread when we measured it, right? I agree that there could be some kind of secondary term due to buoyancy. In other words, it won't spread quite as much as this diagram because it's not so hot and therefore it will mix quicker. Yeah. And in fact, what we found is once you get down to 2 degrees, it really drops from 2 to practically nothing very quickly because you lose the stratification and therefore it's no longer really technically buoyant in the natural turbulence of Corio Bay.
Yeah, I understand.
If that's what you're thinking of.
Thank you.
And the last one is page 107, or the following page.
Figure 5.8.
Figure 5.8, yep.
Okay, the chlorine plumes are calculated from figure 5.5, the big envelopes, right? And so we're saying, well, we know chlorine comes out at, well, there are different numbers, but let's say they're all 40 microgram per litre. And then we get a fairly rapid dilution of 2 to 1 because that's measured on the temperature. You can see it's gone from 10 degrees to 5 degrees quite quickly. So that 40 goes to 20. and then there's a decay, and in an hour it goes down to 10. How far can it go in an hour? Well, not very far, about 100, 120 metres. So those numbers are calculated from figure 5.5, applying the dilution that was measured in the big temperature plumes and allowing for the chlorine decay rate, which was measured and published a couple of years ago. So we're using that chlorine decay rate. For the diffuser, the chlorine decay rates are relevant because it's all done by dilution, really, and it's a very rapid process.
I think there was a related question here, and I'll do my best to put it to you. If there's a difference in temperature differential in respect of the discharge with and without the project, to what extent would that difference in the temperature profile of the plume affect the rate of, volatilisation of chlorine?
A little bit, right? I mean, it's proportional to the Kelvin temperature, I think, more than the Celsius or centigrade temperature. So, and it's the same as summer and winter, right? In summer, you must lose chlorine a little bit faster, and in winter, you must lose chlorine a little bit less. In our experiments, the scatter between experiments was bigger than the summer to winter thing, so we couldn't see it. I mean, I have noticed other people in laboratories have been able to say, oh, well, here's what we find. But what we found out in the fields was you couldn't see that. It must be there. There is a small effect due to temperature, but it's not a big effect.
Okay. Now, having undertaken these exercises, what conclusion do you reach as to the extent to which the project would meet the relevant design or DGVs? Okay,
so in terms of the chlorine DGV, it's 10 microgram per litre for Corio Bay, and I consider that figure 5.8 provides a very good description of the existing extent of impact, which is within the mixing zones, and the future extent of impact will be just the same, right? There'll be no change in the chlorine plumes. In terms of temperature, our predictions are in figures 5.6 and 5.7. So the temperature plumes will be smaller. The reduction will vary with the production rate of the FSAU. So in winter, they'll be much smaller, and in summer, they'll be a bit smaller. That's the outcome that we see for the long, and that's the long-term operation of the project.
Okay.
In terms of using the diffuser, in case you are thinking, what about that? The current proposal is that I have been told is the diffuser will be used for 3 or 4 months every 4 or 5 years. So when they are making a major modification to the plant, their demand for seawater will decrease, and therefore if the FSAU is producing more flow than what the refinery needs, let's say it only needs half, because half the refinery is offline, then the excess flow would be discharged through the diffuser. It's not intended while the refinery exists to ever discharge all the flow from the FSAU via the diffuser. So that's my understanding.
Okay, let's go to recommendation 4.
4 was...
Oh, yeah. Can we go back to you sharing the screen, please?
Yeah. Maybe. Share, yeah, good on you, Ken. Thank you. Wrong. Window. Right. Thank you. Sorry. Has a different sequence to my computer. Recommendation 4 is further targeted investigations to the effect of chlorine discharges, because they will produce chlorine byproducts, of which there's quite a lot. There's general agreement that we can't do direct measurements of chlorine byproducts in seawater in Corio Bay. The way they are normally done is you take a sample and then you heat it up and you measure what is volatilised, and you measure it in the air, right, where you don't have the problem of trying to measure it against sodium chloride or all of the other ions. So we don't have a way of doing that meets don't have a way of doing it. Now, therefore, we continue to use mussels, and you would know that throughout the world people use mussels or oysters to measure contaminants. There's Mussel Watch and Oyster Watch, and they're everywhere. So we're using the same technique there because they're recognised bioaccumulators. Last time for the EES we had the red triangles, and these are mussels that have been there for 1 or 2 years. This time we packed the test sites into the footprint of the temperature plumes, the envelope, except we did have one that was outside the envelope to match. So we had 2 that matched previous sites, so we could sort of compare. And of course, I didn't know what results we were going to get. We had a staged program. We said, well, let's see what we get and then do whatever we need to do to explore it. And what we found is no detectable chlorine byproducts within the ability of the best laboratory in Australia to detect chlorine byproducts. Right? So there will be some there, but they're at a very low level and you can't measure them at the moment. So that's the results. And I did, just by the way, consider testing swans, because swans live in the chlorine plume and they eat the roots of the seagrass. And I thought, well, that'd be a good thing to test. Also thought about sea urchins, but the sea urchins cunningly left the area at the right time. And after I'd talked to Stantec and the statistical test, he would like at least 4 swans plus 2 control areas, which would be 12 swans all up. And I thought, I don't think this is going to sell, testing 12 swans.
Yeah,
So
what would you have to do to test 12 swans?
collect 12 swans and kill them and test them. And I just thought, ethically, to show that swans are not affected, you do that by killing 12. That doesn't seem the right path to take. So we didn't do it. We didn't have sea urchins. And in a way, mussel testing is the recognised procedure for this sort of work, right? Testing something else would be nice, but mussel testing is essential, right? Because that is the standard way of testing substances that bioaccumulate.
Imagine you had done it and you kill 12 swans and you test the swans and there's you're able somehow to detect a level of CBP within the swans.
Yes.
What then? Is there a measure by which one can assess acceptability?
No, there's not a standard that you compare it with. You can compare it with food grade standards, but I don't know that swans are a recognised food source. So you don't have something to compare the results with, right? That's the second part of the problem. That with mussels, you're really saying, well, how much can we detect? And when we look at some of those samples, there is a limit set in the National Water Quality Management Strategy, right? But otherwise, you have a number, but you have nothing to compare it with. So, you know, that's research and not environmental impact assessment.
Are there any guidelines or standards that specify a level, a designed guideline value in respect of the bioaccumulation of byproducts of chlorine?
Yes, well, for some, right? For some of the chlorinated byproducts, there are standards set in the National Water Quality limits, I suppose. And we've made a list of those in the EES, but they're all quite large in comparison to the numbers that we are testing for. There are a lot of other byproducts where we don't know that a number has not been set. So maybe you could detect it if you ran some very clever research program. But then you don't have a guideline to say, is that acceptable or unacceptable? So
how do those levels compare to the level of detection available in the best laboratory in Australia?
Well, the level of detection that we had was 10, 20 microgram per litre. So these are quite low levels. And you would expect, if you could detect it, it would be 1/50th, 1/20th of that number. So it's quite a long way down. And so it's, quite a long way to go for a laboratory. The only people I know who do it are people doing PhD projects where they can really focus on polishing up their analytical technique much beyond what a commercial laboratory can do.
Okay, thank you. Let's move to the next recommendation, recommendation 5.
Next one was to rerun the entrainment modelling, and that was done. We did do quite a bit of work to work out, well, where do the fish come from? Where should we release our particles? So we had interviews with Professor Jenkins, who said on the basis of his studies he could find 18 species. We tried the eDNA method, which is a new innovative method, and you'd probably be familiar with it, where you look for DNA fragments left by fish over the last day or two. And that worked quite well, and we found 14 species in 5 tests. But you're limited by the library of eDNA. In other words, they tend to look at commercial species or species that are of interest, where there are lots of little cryptic species that no one cares about, and you don't have a DNA sample for them. And then we had interviews with anglers who were there, and they were pretty confident there's 20 to 25 species, which is more than Professor Jenkins found and more than the eDNA species were found. But the outcome of all that is they all breed in the seagrass, except for one that might breed on the mud. So therefore we released our particles in the seagrass, and that's why we did it that way.
Before you move off from the eDNA topic or exercise you did, to what extent was the eDNA analysis called for in respect of the supplementary statement?
Oh, it wasn't called for at all. It was an extra innovative idea we had to see if it could add some extra information.
Now, Dr. Edmonds says, it's a good idea, but you had low sample numbers, as I understand, is the critique. What would you say in response to that?
Well, we got 14 species, so that wasn't too bad. I thought it was pretty good. And we did 5 samples. So my view is that was enough to demonstrate what we're seeking to demonstrate. We found 14 species who generally breed in seagrass, right? That's what we're intending to establish. If we'd done twice as many, we might have found 18 species that breed in seagrass. Wouldn't be any different. So you can always do more, but in this case it wasn't necessary to do more. So this is the results of the rerun entrainment model, and as far as the refinery intake is concerned, it came out with the same result. As far as the FSAU intake is concerned, it came out with a slightly smaller result. That's probably because we adjusted the area of Ramsar a little bit, between the 2 models. But in our view, the results are essentially the same, right? So we reran it and got the same result, and it's a small number.
Before you move on from this topic, the main complaints advanced in respect of this aspect of your assessment by Dr. Edmonds is that you didn't model what was called a recruitment shadow, as I understand it. What would you say in response to that?
The recruitment shadow. No, we didn't model the recruitment shadow, but the recruitment shadow, not modelled, but the recruitment shadow would be the same as the envelope of the temperature of plumes. So that would be the recruitment shadow, because you take the water in through the FSRU, you treat it and chlorinate it and run it through a heat exchanger, none of which is very good for fish eggs, and then you put it out through the 4 discharges, and therefore in the discharges you would assume you have 0 fish eggs. I mean, actually our monitoring showed you get 20% somehow managed to survive, but nonetheless, so the shadow is really the plumes that come out of the 4 discharges, and the shadow becomes smaller than smaller. So not long, so within 50 metres of coming out of the discharge, it's diluted 2 to 1. So your shadow has gone from minus 100% to minus 50%. And so you can take each of those contours and convert them to a percent of a shadow. So there are fewer fish eggs in the plume area. So when you get down to the 2 degree contour compared to 10 degrees, that's a factor of 5. So your shadow there is 20%, right? So you've got 80% of fish eggs at the 2 degree contour, if that helps you understand the shadow.
Okay, let's move on. Recommendation 6.
Recommendation 6 was to rerun the sediment transport model with revised inputs. And further qualification was consider a worst case scenario for sediment fractions and settling rates. And we took that quite seriously because there was a lot of discussion about a particular very fine fraction, and there was a lot of discussion about what the right settling rates were. So in terms of the fractions, I went back and analysed the extra boreholes that had been collected after the EES, and then I went to the laboratory where the boreholes were stored and got them all down and had a close look at the clay fraction. And I took some samples of the clay fraction. I took them to our laboratory. We did some settling tests by grinding them up. But what I noticed was when I put the clay sample in a jar of seawater, it stayed there for a week without spreading or dissolving or turning itself into particles, because that clay is very sticky and very cohesive. I discussed it with Boscalis and they said, oh, well, yes, when we dredge the channel, there's quite a lot of a fine fraction, which is not much clay, it's a fine silt and organic matter. But when we do deep dredging, like dredging for the port or dredging a new shipping basin, then the clay fraction tends to stay in lumps and settle out. So the 5% might be a bit high. So from that, though, we took the point that, but when you dredge the channel, you find this organic fraction. So we sent our divers out to have a look, and they said, well, north and around the jetty, there's a fine fraction, and that probably comes from the boats and the tugs and so on, stirring things up. So I got them to measure it, and we included that fine fraction in the revised modelling. So we didn't think about it as a worst case sediment fraction with slow settling. We actually put it into, this is our expected case. Our expected case is it's got an extra fine fraction with an extra low settling rate. So I think we've addressed the recommendation as well as we can without addressing it by saying, well, here's what happens if we just look at the sediment cores, which don't have that fine fraction, because you can understand if you're on a boat dropping a 150 metre diameter steel column, you don't get a fine fraction in the bottom. The turbulence of it removes it, and you can only go and find the fine fraction with a diver or by talking to the dredger who's dredging the channel. So that's how we found the fine fraction, and we put it in. So I think that is our expected case. Our worst case, we looked at the boreholes and said, well, sometimes you can get more silt. And so our worst case is, for a while, maybe a week of the 8 weeks, you could have 13% more settling material. So we have our expected case, which incorporates what we think is pretty conservative estimate of spill rate and settling rate and fractions, and a worst case, which is a bit worse than that. We haven't done hundreds of worst cases, and I don't think that's a prudent decision to take, because, you know, let's suppose you've got 10 weathers and 10 lots of spill rates, that's 100, and I run them all, and then I've got 100 cases, and then I plot a 50 percentile and a 75 percentile and a 90 percentile and a 95 percentile, then I've got 400 cases. And it's pretty easy to get lots of cases, and I see that myself when I'm a peer reviewer. And I think, what do I do with all these cases? How do I take the worst case, or where do I look? So I don't take that procedure myself. We say, what do we think is the most expected outcome? And we compare it to what happened in the previous dredging program. In other words, our view is it's best to validate the model as best you can, rather than produce a whole spectrum of possibilities and leave it to someone else to decide which one to select. So it's a different approach. I won't say that our approach is better or worse than anybody else's. I just think it's the right way to go to reach the answer that you want to reach.
Just on that question of worst case, the direction in the recommendation called for worst case analysis of sediment fractions and settling rates.
Yep.
The critique of the work advanced yesterday was that worst case scenarios should take into account other variables such as weather and spill rates. To what extent are those factors the same or different to the particular worst case scenario that was called for analysis under recommendation 6?
Okay, well, let's take weather. We actually frequently, not twice a year, analyse year-to-year variations in weather, and have actually done it at Port Arlington in 2022. So you look to see, well, we look over 5 years to say what is the variation in wind speed and direction and frequency over 5 years. Turns out to be pretty small, except for easterly winds. Right? Melbourne has, you know, roughly the same number of north, south and west winds, but easterly winds in Melbourne are rare. And some years you get some and some you don't. But easterly winds are not particularly relevant for the Corio Bay dredging situation. It's really southerly winds, as I'll get to in a minute, or as quickly as I can. We use a 2-week seagrass response interval, and therefore we have an 8-week dredging program, and we looked at the worst 2 weeks, which are actually 2 weeks of significantly adverse weather. So in a way, I would say we have taken the 75th percentile of the 8-week weather conditions, and that is smaller than the year-to-year variation in weather conditions. I'm sorry, what was the second half of your question?
The second question is, to what extent are those factors the same or different to the factors that were identified within the recommendation as being required to be taken into account to determine a worst case scenario?
Right. The biggest factor is the spill rate. Right. If you have a 4%...
And is that the same or different to those that was...
It's different. In other words, the two factors that are in the recommendation we took into account in developing a worst case scenario.
Okay, thank you. Can I invite you to turn to the slide that's headed Revised Inputs for Sediment Transport, please?
Yes.
And in the third dot point there, you explain the average period that you adopted for the purposes of your analysis.
Yes.
And this was identified in the conclave that you completed with Dr. Edmonds as being a major point of disagreement between the two of you. Can you explain why it is that you selected the 14-day average period for the purposes of your assessment?
We selected the 14-day average period because I believe there's general agreement amongst seagrass published works that the response period for seagrass is more than a month. Right? More than a month.
Did you say more than a month?
More than a month, yes. And I have got a slide, which is later, but this might be, perhaps it's in the wrong spot. It's the WA EPA Assessment of Marine Dredging Proposals. It's their guideline. And they say for mixed meadows, remember these are tropical meadows, the response time you should assess is 12 weeks. That's because they're thinking of 2 and 3 year dredging programs, but they're not talking about a day. They're talking about 12 weeks. And then you look at the peak 5 days for a tropical seagrass meadow because it gets a lot of seagrass.
You mean 5 days in 12 weeks?
Yeah, 5 days in 12 weeks. And then for halophilia, it's 3 weeks. And we've got halophilia. So from this, we say, look, 2 weeks is a reasonable period to assess the response of seagrass to light. Therefore, coming back to the question, every day will be slightly different. You have a barge with a big backhoe on it, dumping into 2 other barges that carry it out to sea. And it's on a 4-hour cycle. You spend 2 hours filling up the barge goes out for 45 minutes, it spends 20 minutes dumping, it spends 45 minutes coming back, and then it's got a little bit of time for crew changes and refuelling. It inevitably gets slower now and then because there's another ship coming in, and therefore it'll have to wait and stay behind. So, and that cycle won't be exactly 4 hours. It'll vary a bit during the day. But that doesn't matter because you've got a pool of turbid water which has got an average period of 1 to 2 days. So the hours are little blips. You see them close to the dredge, but further away, turbulence spreads them out. So that's the first thing. But the second thing is seagrass naturally experiences variations in light. I mean, there's day and night, right? Seagrass has 14 hours at night during winter where there's no light. And you can have a night and a day of poor light and another night. So seagrass is naturally growing in an area with variable light, and it has processes to accommodate that, which is really moving energy between the roots and the leaves. So yes, it is a fundamental part of our analysis that 14 days is the appropriate period to assess the seagrass response, and therefore variations that occur over a few hours or a day or two are not particularly relevant to what happens as far as the seagrass a kilometre or so away is concerned.
Do the Victorian dredging guidelines provide any guidance about appropriate timeframes?
The Victorian dredging guidelines, yes, do. They don't have a response time. What they say, if I can find it, is Victorian dredging guidelines say where dredging will significantly elevate turbidity levels by more than 15 days in summer or 30 days in winter, seagrass communities may be at risk. So that reference is in the Victorian dredging guidelines. I don't know which page offhand, but I think you'll find it in Appendix 5.
Now, Dr. Edmonds suggests that a different approach should be taken, that consideration should be given to hourly variation and daily variation. Are you aware of any standards or guidelines that specify relevant threshold values that might be adopted for the purposes of an assessment of that type?
No, and I'm not. Most assessment periods are 14 days and 30 days. So in Queensland, if you're doing dredging, you assess over 14 days and 30 days.
Okay. All right.
So, no. But, I mean, obviously seagrass responds every hour because during the day the sun rises and sets and therefore the seagrass responds to that. But, no, I'm firm in my view that 14 days is the appropriate response time for seagrass. And that takes into account the variation in turbidity that the seagrass in Corio Bay will see. So if I get it, I'll try and go faster.
The one other topic on this slide that was the subject of questions yesterday was the approach that had been taken in respect of what I'll call ambient or background suspended solids and the extent to which that, or how did you take that into account?
We measured a background suspended solids and used an average value, but when I show you the variation in predicted suspended solids over time, I will explain that in reality background is fairly constant when the predictions are low, because that's at a time when the wind speeds are low. And when the wind speeds are high, the background goes up a lot.
All right. Why don't we turn to the next, is that the next slide?
Oh, it is the next slide.
Okay. Can you explain what this is and
yes,
what you want to say about
Yes.
it?
So this is the predicted variation of suspended solids from the model without background for sites 3 and 4. I mean, we did sites 1, 2, 3 and 4, but 3 and 4 were the highest. So and the key is that it's very variable, right? You can see that there's intermittent periods of low suspended solids when there will be good light. And the literature tells you that when you have intermittent loss of light and then light, the seagrass just adjusts, and probably 14 days is not a long enough averaging period. Under intermittent light, probably 30 days is a lot more appropriate. But nonetheless, we've stuck to 14 days. When you get these high peaks, the background will go up a lot, right? And if you look at site 3, the top one, the highest number is 25. And at 25, the light is down to about 5%, right? So nature, and you get, there's a measured 30, I think, in Corio Bay, one day in 10 years. So nature does not provide the IACs 20% every day or every hour, right? You have to think about it as to, well, over what period does 20% apply? Clearly it doesn't apply at night. Clearly it doesn't apply when it's a cloudy day. So what averaging period would we use? Now, we could say, well, we picked the lowest of the Western Australian numbers, which are 5 days. We could say, well, you know, we're really most concerned about Halifilla. So the averaging period for that is 3 weeks. So we compromised on 2 weeks. I mean, that is reasonable for a system where you have light, little light, light, little light, light, little light, right? The seagrass will continue to grow through that kind of pattern. We then add the background, which is a constant background, recognising though that there should be higher background in the peaks, but we're assuming there's no light in the peaks, really. Now, I know that
you were going to explain, I think, why it is you formed the view that the background suspended solids would fluctuate in a similar way to what you've modelled in respect of the...
okay. We've formed the view because when you are on Corio Bay in a boat in stormy conditions, the background is turbid, right? It's not an average background. Most, you know, Corio Bay gets a number of storms. Every time there's a strong southwesterly, it becomes turbid. And then as soon as that wind swings around through the east to the north, all that sediment drops out again and you go back to clear. And in fact, you know, the process that really happens is you make a big mixture of sediment and water and you push it out to Port Phillip Bay. and clear out some of the sediment into the western arm of Port Phillip Bay. But in terms of trying to assess the impact, we looked at it in 2-week periods because we believe that's the seagrass response time, or it's a conservative estimate of the seagrass response time where it's getting regular periods of light within those 2 weeks. You're not getting 2 weeks of low light, you're getting 2 weeks of variable light. Looking at the lower graph, I know there were a number of comments in the conclave about why didn't we do 95%? And the answer is because it's a skewed distribution, right? If it's a normal distribution, you can look at the 95% and that makes sense. But looking at the 95% for this distribution, you can see it's just picking up a few of the points from the high points. In the record, there's actually 14 high points, and they range from 2 to 6 hours. That's the duration of these predicted high points. But if you collect all the 6 hours and put them together, you get the 5%. That something doesn't actually occur, right? It occurs in 14 separate little events that are separate. So I don't believe the 95% is a useful statistic for this type of skewed distribution. I've given you the 95% in case you'd like to know what it is, but I don't think it shows you much. Oh, why have I not got any more slides?
I was hoping we'd finish by 1, but we're not going to do that.
I'll try. I'll try, yeah.
Okay.
If I can have to 105, I can do it.
Okay.
But Ken, can I just find out where my slides have gone?
I think they're back now. It was Dr. Wallace. It's just caught up with. It's on the screen now.
Is it?
Oh no.
Well, why has it disappeared? No. Well, while he finds out the answer, let me tell you a couple of things. Right. Validation of the model, right? So we can validate the model by looking at previous water quality data collected during previous dredging programs. In summary, they found that during the previous dredging program, turbidity was generally in the range of 0.5 to 2.5 NTU. And our model predicts 1 to 4.8 NTU. So we're a bit higher, right? Not way out of scale, but in the right scale, and also a little bit worse, if I can use that, but not the worst, but yeah. So we think we're about right on water quality data, and we also predicted, we also took a plot that Lawson and Treloar developed in the previous dredging program. They developed 4 models because they found their worst model was too worst. And they finally got a model which said that matched what they observed, right? So we have said, all right, let's compare what we predict with what they observed. Ours is a bit bigger, but it's pretty similar. It's also got 2 and 5 milligram per litre turbidity contours. So at least on those 2 tests, we are saying, well, we think our model is validated because it matches what happened in the previous dredging program. Same place, same sediments, same production rate. Actually, well, we don't know if it's the same contractor or not. Depends what happens. I make some comments on the sediment model and some responses to comments which you don't need to know. But the adaptive management of dredging is what you do need to know, which I'll just go through if I can find. Do you want me to load up my...
I need to put the disc back in the side, yes.
Yeah, right. Okay. We've run out of what it's remembered.
We've got the slides on our own screens. If we just know which slide you're talking to.
43.
43?
As a starting point.
Validation of sediment predictions.
Right down the bottom, yeah. Yeah, I can find it.
Member Cole, I did have a couple of additional questions arising from the discussion yesterday and things that were put to the other witnesses that need to be put to Dr. Wallace. I don't think we're going to get through it in 5 minutes. Is this an appropriate time for
I think
lunch
we
while we
might,
work out
given
the
that's and given
computer?
my stomach is starting to rumble, I think we'll break now and we'll resume at 2 o'clock.
And could I
Thank
just
you.
ask Dr. Wallace also, I just wanted to ask a few questions after the break about slide 42, those time series plots as well.
Okay, yes.
Why don't we pick up there, perhaps? And thank you.
Okay, if I could just remind everyone who's observing online just to make sure that you keep your microphones muted. We just heard a conversation at the end of this morning's session that I'm not sure you're intending people to hear. So if everyone
Member
could
Carlisle,
just...
you might be muted at the moment.
Oh, I've got my microphone on.
On the image behind you, it's got...
Oh, no, that's okay.
Oh,
this
I'm sorry.
picks
Sorry
up...
to interrupt. Sorry.
Yep. So yes, if everyone online could just stay on mute. Thank you. Back to you, Dr. Wallace.
Thank you. Dr. Wallace, we'll start, please, with the slide that has the predicted time series of... Yep.
Are we good?
Yes. Thank you. Okay, thank you. Can we please pick up at the slide that shows... Yes, that one. Thank you. And can you start by explaining what this shows?
Yes, okay. This is the probably 15-minute average suspended solids concentration over an 8-week period for two of the 5 sites, actually, we analysed, but these are the 2 biggest sites, so that they are the sites in the northeastern area where the turbidity goes first after leaving the dredging. The top slide, or the top panel, is site 2, and so you can see the variation in predicted
The
suspended
notation there
solids.
says site 3. Is that
Oh, I'm sorry. I'm not reading it right. The notation is right. It is site 3. And that's the variation at site 3 over this short time interval. And as I mentioned before, you can see the various southerly wind events that come through on a regular basis every few days, more of them in the first period in August and fewer of them in September. And you can see there are periods of quite low suspended solids concentration where the light will be barely affected. So seagrass will receive quite a bit of light over that period. I showed the background which we added, which is 1.8 milligram per litre, which is what we measured up there. And then the lower one is for site 4. You can see it's similar but slightly different. I mean, the storms appear there, but they are slightly different at different sites. And then I'd worked out the 95 percentile of that concentration distribution and pointed out it's not a continuous event. It's a series of quite short events of 6 hours.
And if one were concerned with the impact of dredging upon the productivity of the seagrass as opposed to its survival, and was concerned with an analysis over periods of hours or periods of days, what would this time series suggest as to the likely extent of effect?
This time series would suggest, I mean, there are 14 events that last for 6 hours. Half of them, on average, are going to be at night and half by day. So there are 7 events where photosynthesis would effectively slow down and so on. But that's a natural event that seagrass experiences. That there is no threat to seagrass survival in this record. There is extra turbidity and a reduction in light, but it's remaining above the level required for seagrass survival and growth.
But that's not, the light levels aren't actually shown on
No,
these
it's not.
plots.
It's not. The calculated from this record, the light remains at the level where seagrass will survive and grow.
Okay. I understand how to read the dotted line on the Site 4
Yep.
spectrum. I don't understand how to read the dotted red line on the Site 3 spectrum.
The dotted red line is we added 1.8 milligram per litre, so that's just to show you 1.8 milligram per litre in comparison to the predicted contribution from the dredging.
That remains constant across the time period, which in reality we know is not going to happen.
Yes.
But would you expect? So should we be adding to each of the blue peaks?
Yes, we should.
And the troughs, an extra
Well,
1.8 effectively to.
The numbers that we measured varied from 1.5 to 2.3, right?
Yes.
So it varies up and down even in a trough.
Okay.
But
it doesn't vary as much as
but certainly you should be adding more in the peak periods. Yes. But they're very short and don't make any difference to what happens to seagrass.
Okay. Do you understand all that?
I do. Yes. So as I understand it, the graphs you've given us there, the values don't have the background added in. They're just.
That's correct.
They're just the effective.
They're just the modelled.
Yeah. And I'm a little bit interested in what happens around about the week 2209. Just before that, there's a peak that's quite pronounced, the largest peak at Site 3.
Yeah.
There's only a very small peak at Site 4. Is that a peak as a result of dredging, something happening with the dredging or something happening with the wind?
Something happening with the wind. So it is more of a southwesterly wind than a southerly wind. And so the pool or the plume coming from the dredge bypasses Site 4 and goes directly to Site 3. In fact, strikes Site 3 straight on.
Understand that. So in terms of these plots, do you have the similar ones for 1 and 2?
Yes, there are. They're in the report.
Okay.
Couldn't fit them all on, but I think they're figure 8.8. Yes, so figure 8.8, page 8, 128, there's sites 1, 2, 3 and 4.
Thank you.
Of which report, sorry?
Of technical report A.
Can you explain why it is you selected those 4 sites for the purposes of the time series analysis?
I selected 4 sites, which are shown on figure 8.7, because they...
Just for those following, that's 8-127 and 8-128 is the hard copy. I don't have the PDF to hand, but these are references to technical report A.
Yeah. So we are looking at light in the Ramsar site, therefore we need suspended sediment concentrations at the boundary, the outside of the Ramsar site. So I put on 4 points to predict the concentrations at the edge of the Ramsar site. For the light analysis, we then picked the highest, which happened to be Site 4, and then we picked the highest 2 weeks at Site 4. So there are 16 values, each of 2 weeks, and we picked the highest one. It's not exactly a 1 in 16 percentile.
Okay.
But that'd be a 94 percentile if I did it that way.
All right.
Okay, move forward.
Yes, can we move next, please, to the slide that shows a comparison between the predictions with the L&T predictions?
Yes.
And I'll just ask you to please explain what that shows and what that is intended to demonstrate.
This is part of our demonstration of the validation of the model predictions. So the left-hand side is the predicted increase in average suspended solids at the surface from the hydronumerics model with the parameter values I've discussed. The right-hand side is a report by Lost and Trelaw, who were the consultants for the 2008-2009 dredging program. they made a model before the dredging program, which proved to be a worst case. So after the dredging program, they made what they called a verification model, which, in their words, predicted what had happened during dredging. So this is a completely different model by a completely different consultant with a completely different set of parameters, which they believe best represented what happened, which predicted a pattern of turbidity. The outside in each case is 2 milligram per litre, and the small area in the middle is 5 milligrams per litre. And you can see the 5 milligram per litre zones covered different areas because Lawston and Treloar were digging out a different part of the bay, nearby, but different, to the boomerang shape that's proposed as part of this project. And our view is the shapes are similar. The shapes from our model is slightly bigger, but not a lot bigger when you compare predictions of 2 milligram per litre suspended solids. And we're saying, well, that shows that we're predicting what occurred last time, and we're a little bit conservative. That is the point of that slide. So we're saying, well, that's what happened, and we're predicting pretty close to what happened. And that's a reasonable basis for saying, well, we validated the model.
So was the Lawston Treloar also based on median values?
Yes, that is their median value. And so there would be all those sort of little short-term peaks as well.
Okay, can we turn next to the slide headed response to comments on 6?
Response to comments on 6, there's not many agreement. It's agreed that the background suspended solids was measured and the average suspended solids was 1.8, and that was added to the model results. So we ran the model quite separately without background and added the background later. It's in one of the tables in the report. I could find it if you like. But
Don't worry, we can find that if
right.
we need to.
There's a table there in section 8. Okay, comments which were other than agreed. There should be a time series input of background suspended solids, and we don't disagree with that, except we don't have a time series of background suspended solids for 2022. Dr. Edmonds believes we should be making calculations at an hour to sub-day scale, which we don't agree with. We agree that's appropriate if you want to look at photosynthesis of seagrass, but we don't agree it's appropriate to look at the long-term environmental impact of an 8-week dredging program. We disagree that light impacts should have been plotted throughout the model domain, because for that you'd need to know the background suspended solids at every point, at every time, and go through. And we think the way we've done it is more appropriate for the committee to assess the impacts, and I'll show you an important slide in a minute. It was agreed that additional calculations should be provided to demonstrate the effects of the worst case scenario in terms of light availability seagrass, and that is understood in 3 parts. One is the additional calculations were the calculations that we did and summarised in the report, and there was a feeling that some people, the people in the conclave, would like to look through the whole spreadsheet and see how that was done as opposed to a summary of it. We didn't have any problem about providing our calculations. But later, once the baseline study is done, there is a whole calculation of light inputs at each of those monitoring points that goes into the marine report, that goes into the planning people. So there's a whole lot more calculations to come, and it's agreed that they should be provided. And
Are they calculations that, in your view, need to occur now in order to allow the committee to assess environmental effects?
I don't think so,
Why?
because I think that both Dr. Dr. Edmonds and I have agreed that the 20% light will be met in the Ramsar seagrass. So that is not an issue. So therefore, I think the key question that you asked has been answered, right? There will be 20% light in the Ramsar seagrass. The additional calculations, therefore, really come around to what's going to happen at the edges of the halophila in the rest of Corio Bay, and I'll discuss that in a moment. And the last one is...
That's really about light, isn't it?
Yeah, that's about light.
All right, we'll come to that in a moment. The only other one I wanted to put to you is, in the modelling conclave, in respect of recommendation 6, there was an agreement that some discussion of short-term peaks in suspended solid concentrations should be provided, as well as the 14-day and 30-day averages. What did you mean by that, and to what extent does that require additional discussion at this stage of the process?
Well, it's really the discussion I've just gone through about how you interpret figure 8.8. The feeling of some was that the implications of those peaks hadn't been fully addressed. I thought they had been addressed, but nonetheless, we could write more about how you interpret the peaks.
Okay, and were you to write more, would you say anything beyond what you've said today?
No, I would just write down what I've said today, actually.
Okay. All right, thank you. Let's move on to the next slide. I think you wanted to say something about adaptive management of dredging.
I want to say something about adaptive management so that you understand how it works. So during dredging, there will be this array of turbidity and light measurement on the 3-metre contour. That's before the edge of the Ramsar zone. And for example, if it exceeds 15 NTU for 12 hours, then there's a warning, goes to the regulatory authority and to the dredging contractor. Turbidity's up. If it stays above 12 NTU or some other agreed threshold for 24 hours, then the contractor has to reduce the spill rate. And the easiest way to reduce the spill rate is to stop the overflow from the barges, which slows the dredging process a bit, and that reduces the spill rate by about 30%. So he can easily reduce the spill rate by 30% at a cost of, taking longer to do things. If it exceeds the threshold for 48 hours, then he has to slow or reduce dredging or take some other action to get it back below the threshold. Now, according to our modelling results, you will not exceed the threshold of 20% light for 48 hours. Won't occur, but it might. This is a model, and things are different in reality sometimes. It may be that when the dredging occurs, there's 8 weeks of very favourable weather and nothing happens and the contractor's very happy. It may be during those 8 weeks there's 8 weeks of terrible weather, in which case the contractor's got to adjust his behaviour in according to what the measured NTU is. My point is that the adaptive management prevents a whole lot of worst case scenarios happening. There's a cut-off. You can't get to find worst case. If you get down to 21% light, that's it. Got to stop.
And where is that light monitor at 3 metre steps?
It's the one shown in that baseline study. You see there's
Yes.
a series of 3 light monitors and turbidity monitors which are just outside the boundary.
Okay, so it's
of the
measuring at
Ramsar.
the edge of the Ramsar.
A bit offshore from the edge of the Ramsar. It's a bit late by the time it hits Ramsar. So yes, it's offshore from the edge of Ramsar.
And But there's no trigger for adaptive management for seagrass or for light levels outside the Ramsar site?
There is one monitoring site on the refinery seagrass, so there is one. Yes.
Okay, there is.
Yes.
Okay, thank you.
Can I ask a question about this? To what extent does your modelling take into account the application of adaptive management measures or other forms of physical amelioration like the silk curtains that are proposed?
It doesn't. The modelling is for the unmitigated, unmanaged dredging. And so obviously the most obvious one is stopping the barge overflow, because that's easy to do and direct. And it has a cost implication for the contractor. So he will try to manage operations so he doesn't have to do that, or only has to do it once. So the contractor, I know from working on the dredge, you're looking at this signal all the time and adjusting your behaviour to make sure you don't exceed the threshold, right? Because that's a cost, significant cost. In terms of the silt curtains, you'll find that I'm recommending a silt curtain between the barge and the nearest seagrass, which is the seagrass on the refinery shore, to minimise the impact on the seagrass I think is most exposed. But we haven't taken that into account in the modelling. That will certainly reduce turbidity there. But look, it's very hard to work out what really happens, and it will reduce turbidity when there would have been reasonably medium to low turbidity. It won't reduce turbidity when you get those peaks, because the silt curtain will simply be deflected by the current at that stage.
Okay, thank you. Recommendation 7, please.
Recommendation 7 is to look at the light impacts of 10% and 20%.
And why did you look at 10% and 20%?
Because they were specified by the IAC in the recommendation. So there's 20% light for seagrass in Ramsar, which goes out to 2 metres depth at the height of the seagrass receiving light. And for the rest of it, we've taken it out to 3 metres. There is a little bit of scattered seagrass beyond 3 metres. Okay, and then we had to grapple with what is the seagrass response time, because you can see with this very variable signal, you have to make a decision about what is the appropriate response time. We looked at the Victorian dredging guidelines. I've read that out. We looked at the WA dredging guidelines. I've got that to show you in a minute. Gladstone, they talk about 2 weeks to 30 days and 2 weeks to a month, really. And that's based on their test that shows that seagrass is impacted after 4 to 8 weeks of continuous shading. And if it has intermittent shading, then it lasts for a long time longer, which will be long after our 8-week dredging program. Moreton Bay, and again, their seagrass continued for several months at 5% light. And from looking at these studies and guidelines, we used 14-day averaging for light assessment on seagrass. And we used the highest of the 16 values. We picked the highest 14-day averaging for assessing did we or did we not meet 20% light. And this very important summary, right? In summary, we say all seagrass in the Ramsar site will receive more than 20% of available light during the dredging program. That comes from the unmitigated predictions of the model, including the constant background. But it also comes from understanding that the adaptive management program will control the dredging to achieve it. So there are 2 reasons why we believe that's the case. And Dr. Edmonds has made his own calculations using our formulae, and he agrees that you will get 20% there. So it's not in dispute.
Just before we go on, how conservative is that 20% surface irradiance figure?
Look, there's a range of opinions on that topic. Many people would think that 12 to 15% would be appropriate over an 8-week dredging program. And in winter, you might think that 8 to 10% would be quite appropriate because seagrass is not growing very much at all. So that 20% is quite conservative, and I assume that's what the IAC had in mind when they set 20%. They set 10%, which seems a probable, reasonable limit for seagrass in Corio Bay, and then they said, well, this seagrass is special, so we're going to have a much more conservative limit. And so that's where they came from. I think they're conservative.
Okay, thank you. Your next point?
My next point is almost all seagrass in Corio Bay will receive more than 10% of available light. That there will be some deep, sparse seagrass near the dredging site. You get these isolated little parcels of seagrass that may experience a setback in growth rates during the dredging period. That, in theory, there's got to be one plant which is growing at the limit of available light. So if you just add a bit of turbidity, that plant will suffer. But as I've shown, in that area of 4 to 5 metres, plants are very sparse, right? And they come and go. And some of those probably will be affected, not to the stage they're all going to die, but some of them will, their growth will slow. If it's in winter, they're not growing much anyway, so it won't make any difference, really. But
Dr. Wallace, one of the things that is said in respect of your analysis is that of the 4 points you've selected, only one's located outside of the Ramsar wetlands. How is it then that you form the view that you have in this second dot point?
we formed the view using the distribution of sediment that's presented in our report in one of the figures. So we didn't just calculate from the 4 points, we actually calculated around the contours of the predicted sediment concentrations, which are in figure 9.4. Okay, so we looked at what's the distribution of sediment in Corio Bay and made our assessment based on that, as well as the 4 points.
Can we please have figure 9.4? Can I ask the committee and others to have figure 9.4 in front of them? That's in the technical report A. I don't know whether we can. Nine dash four. It's on hard copy page 9140. I've got it on the screen at the moment. Thank you very much. Now, you've expressed the view almost all seagrass in Corio Bay will receive more than 10% of available light during the dredging program. You've explained that you've ascertained this by reference to the contours of average suspended solid concentration. Can you identify by reference to this plan what area would likely receive less than 10%?
The areas outside the 3 milligram or inside the 3 milligram per litre contour, plus 13%, which is our worst case allowance. So you can see that 3 milligram per litre contour gets quite close to the area of regular seagrass, and inside that there are going to be some patches of seagrass, and you can also see it just covers a small patch of seagrass next to the jetty. Now that seagrass comes and goes depending on the seasons, but in forming the conclusion, I didn't want to be too absolute and say all seagrass in Corio Bay will always receive 10%, because that's not completely the case. there will be some isolated patches of seagrass in deeper water which will have less than 10%.
And that's a mean figure over a 2-week period, is that right?
Mean figure over a 2-week period.
And throughout that 2-week period, what would you expect in terms of variability?
A lot of variability, and I think the variability will very likely mean that there's a very small reduction in growth, right? I mean, if there are patches of light in that 2 weeks, then the seagrass will probably survive. But it certainly will survive. We'll probably keep growing. But we only have information for seagrass that's completely covered, so shaded for a month or 2 months or 3 months. And generally those experiments show there's an effect after 30 days, thereabouts, plus or minus a week. Or you have seagrass which is covered for 7 days and not covered for 7 days and covered for 7 days. And that lasts for a long time. But we don't have information for seagrass that has very poor light for 1 day and good light for 2 days and poor light for 1 day and good light for 3 days, that you're extrapolating beyond the experiments that have been conducted. So I don't want to be too overconfident in saying that will be fine. I wish to express a reservation that I think there may be a setback in growth rates, for things inside the 3 milligram per litre contour.
Thank you. And just to clarify, did you say mean or median? These are based on.
I said mean, but maybe I should have said median. What is it, mean or median?
Yeah, that's been a problem for us because Peter gives us, Dr. Yates gives us figures that are averages and medians and means. And so this figure, 9.4, is a median figure, right?
A median.
It's labelled average, and average includes mean and median, but I should have labelled it median.
Thank you.
Okay, thank you.
Okay, and then I'll just respond to the 3 comments. I mean, I suppose you can read that, and unless you want me to discuss them.
Can you share your screen? I mean, one of the criticisms of your analysis here is the method by which you've converted your estimations of suspended solid to light penetration through to the seagrass. And can you explain what approach you used and why it is you used it?
Yes. We used the equations that are set out in Appendix 5 of the Victorian Dredging Guidelines. And those equations were derived by the Victorian EPA specifically to convert from suspended solids to turbidity to light attenuation coefficient in Corio Bay. They were derived during the earlier dredging program. So we feel they are the best equations available to reflect what happens in Corio Bay. There are 2 equations provided in Appendix 5. We then looked at the EPA monitoring data over the last 12 years and derived a 3rd equation. So we had 3 equations. The 2 equations that are in Appendix 5, I think, give slightly different results. One is obviously higher than the other, and we've used the numbers for the lower equation. The data derived from the EPA latest correlation gives even higher results. So we worked out the numbers and we didn't use them. And for a comparison, if I give you a comparison, I think one equation says there's 24% light on average over 2 weeks, in the worst 2 weeks. The other equation says there's 28% light on average over the last 2 weeks. And the EPA equation says there's 39%. So we said, oh, well, 39% is not right. The 24 and 28 are fairly close. We'll quote the 24%. That's the number we've used in the document. So all the methods confirm there's 20% available light will be met. Some show a bigger variation than others.
Okay, thank you. Your next slide, please.
Next slide is a response to a number of comments. I think we've already...
Sorry, Doctor, before you go to that slide,
Yep.
which is the summary, can I just ask one
Yep.
other brief question? You've highlighted in the slides and also in your evidence 3 of the summary points about what the assessment showed. What you haven't referred to is the 4th dot point in the summary, which is on the top of PDF page 159 of 220, page 9-145. And I'd just like you to take us to that one dot point at the very top of page 9-145 and explain the significance of that finding.
All seagrass will recover within 2 months to normal growth after completion of the 8-week dredging program, as rhizomes will not be damaged. Right, so that is from discussion with seagrass scientists. They say, well, this seagrass, the worst that will happen is that the growth will slow. And then when dredging ceases, and it's only 8 weeks, and spring comes along, then that seagrass will grow. So there's not going to be destruction of any seagrass. The worst effect is there'll be a reduction of growth.
Technical person, the rhizomes
The roots.
The roots of the
Yes.
seagrass. And when it says will recover within 2 months to normal growth, does that mean it's not going to, its growing cycle will recover, or is it saying it'll go back, there'll be additional growth and it'll be
Yeah, okay.
what it would have been? Do you understand?
Yeah, it will keep growing. Will it end up a bit shorter because it's had the 8 weeks of dredging program? Look, I don't know. That what you find is seagrass is at varying lengths anyway, and I think its growth is mainly influenced by the supply of nutrients and how deep the water is. So seagrass near the shore, well, seagrass near the shore is not affected. So this is seagrass in deep water. And those are not very long. So will they be a few millimetres shorter? Maybe. Oh, I don't know. I don't feel that you can... They'll be there, they'll be growing.
It's all right. It's all right.
Will they be
Understood.
slightly shorter? I'm not sure.
But I do have to ask, just to be really clear,
Yep.
when you say all seagrass, so it's not just in the Ramsar site, but it's all seagrass in Corio Bay.
Okay, that's poorly worded. Yes, all seagrass that's impacted will recover. Not,
Okay.
yeah, the seagrass in Ramsar will not be impacted to a significant extent, and therefore it'll be just the same as normal.
Okay, thank you.
But, so this is talking about the deep seagrass on the refinery shore.
You're going to go to the colour slide.
This
I think you were in response to, well, before you move on to recommendation 8, I need to put to you certain things that were the subject of discussion in the conclave. And here I'm talking about the modelling conclave, and in respect of recommendation 7, there was an agreement in general that conservative assumptions had been used to derive the estimates of light availability in relation to the 20% and 10% thresholds. And there was agreement that although some conservative choices had been made in the modelling, the most conservative possible relationship for derivation of KD has not been used. Can you explain what that's a reference to?
In making our predictions, we did use the most conservative of the Victorian dredging guidelines relationships. There are other relationships for deriving KD which are published for other sites throughout Australia, and we didn't use the most conservative of those other relationships.
Okay. There was an agreement that zones of impact could have been used, as used in the WA dredging guidelines, and a note that the 20% light threshold requirement in the Ramsar area was effectively a zone of no impact.
Yes,
Can you explain that, please?
Yeah, the Western Australian guidelines talks about 3 zones of impact. Obviously, they must be much more tolerant of impacts to seagrass than we are here in Victoria. So the 3 zones are, for zone 3, the seagrass is completely destroyed. There's none of that here. Zone 2 is the seagrass is severely damaged but recovers within 5 years. None of that here. Zone 3 is there's a zone of influence where there may be some small effect on seagrass. We're probably within that 3rd zone. We're at the bottom of that 3rd zone for the seagrass and Ramsar, right? Because that seagrass is over a kilometre away from the dredging site, and it's a maximum of 2 metres depth. So therefore, it's always got a lot of light. The worst case is right at the edge, which is what we've analysed. So I don't think the 3 zones really apply in this situation, because we haven't got zones of moderate impact and zones of high impact. We're really at the bottom end of the zone of influence. And really, the IAC has set a pretty conservative limit. You've got to have 20% light in all the seagrass in Ramsar. That essentially means no impact. So if you're not going to have an impact, it's hard to divide it up into 3 zones.
You agreed that additional calculations should be provided to demonstrate the effects of the worst case scenario in terms of light availability for seagrass. What did you mean by that?
Okay, I think we've discussed that before. There are 2 types of calculations. One is our spreadsheets, which underlie the conclusions in the document, which some people may wish to look at, probably not the committee unless they're keen on looking at spreadsheets. And we said, well, of course they could be provided. But the more general one is the calculations that are done from the baseline study that form part of the planning approval. And it was agreed that they shouldn't be as short as our discussion in the document. You know, there needed to be a longer discussion of here's the results month by month from the various monitoring sites, and here's the light, and here's the background turbidity, and we'll put it all together in a big package. And that will inform how the MACA regulatory authority sets the thresholds. They may go for 10 NTU, 8 NTU, 12 NTU, who knows? But that's the calculations on which they set thresholds.
Okay, thank you. Let's move on to recommendation 8, please.
Recommendation 8 is just to confirm the EES conclusion that dredging will not impact the Ramsar site. So there's more modelling being done, but the results are quite similar to before. The assessment of impacts is based very much more on light this time than it was last time. So that's been done. And the revised or updated, or the assessment of impacts on seagrass shows that the 20% available light will be met. Dr. Edmonds made his own calculations, which was good, and he agrees that there will be 20% available light. So the EES conclusions on impacts of dredging are confirmed.
Okay.
Next slide. Sorry, I should have had this slide before, but it is an extract from the WA EPA assessment of marine dredging proposals, right? And this is their table of a possible effects guidelines, okay? Possible, not, you know, so they're conservative. The outer boundary of effects. So a mixed meadow, so we would say a mixed meadow, well, probably that's Nigrocaulus and Mulleri and Halophilia. In our case, you specified available light. They're saying they have a different criteria, which is the amount of light that it needs. Okay, so it doesn't say 20%, it says they want a fixed amount of light. And they're saying over an averaging period of 12 weeks, we believe you should need 13.1 mole photons of light, right? That's their formula. So it's a bit of a different formula, but it's just another variation of 20% light averaged over 12 weeks. And then they say within the worst 2 weeks in that 12 weeks, it's not that they want 13.1, they want 2, right? So this is 1/6 of the 20%. Not exactly, but that's how you interpret it. So they're not saying you need to look at it on a day-by-day basis or an hour-by-hour basis. They're saying you need to look at it on a 5-day and a 12-day basis. And for halophilia, which is really the species that is most concerned here with respect to reduced light, they're saying, well, that should be a 3-week averaging period. We've used 2, but their recommendation is 3. And they say it can survive with very small amounts of light, right? So if we adopted their 0.9 over 3 weeks, there'd be no impact at all on halophilia. If Corio Bay was in Western Australia, it would pass with no problems. So that, I think, supports our view, or that's what underpins our view, that a 2-week averaging period is the appropriate averaging period.
Okay, before we move off recommendation 8, there were some conclusions I need to put to you from the conclave, the modelling conclave. I'm at page 10 of 16 for those following the document. The first is that there was an agreement that 14-day and 30-day averages were appropriate, but there also should be a discussion of peak events. I take it we've already addressed that in earlier questions, is that right?
Yes.
There was an agreement that overlapping 2-week windows should be used as a basis for light attenuation calculations rather than 4 non-overlapping windows. Can you explain
yes,
what
so
that related
we've
to?
used fixed 2-week intervals, so it goes over the 8 weeks, you get 4 intervals, and you can use a sliding 2-week interval, and that changes it by about 2%, and we didn't do that.
Okay. So
if it was a 12-month thing, we would do that for over 8 weeks, probably.
When there was an agreement that the overlapping 2-week windows should be used,
yep.
What was that a reference to? When should
that was a reference to, you should have a look at that and see if it makes a difference, and we've had a look at it, and it doesn't make a difference.
Okay. And why doesn't it make a difference?
Because if you look at the predicted values, there's a lot of storms in the first 2 weeks, and if you leave off the first 2 days and add 2 days from the next one, you get very much the same value. And you leave off 4 days and add 4 days, you still get the same value. And the further you go, the smaller the 2-week average becomes, as a matter of fact. It's highest for the first 2 weeks and stays about the same for about 5 days, and then it decreases. So, yep, it's appropriate for a long, I mean, when you're doing a 12 or 24 month dredging period, which you often do in Western Australia, then, you know, I think it's right to use a sliding 2-week scale. On 8 weeks, it's a bit marginal, but we did it anyway.
Okay. The next one I wanted to raise with you is an agreement that additional calculations should be provided to discuss the worst case scenarios in terms of light. What did that agreement relate to?
I think it's the same one, right? People wanted to see the spreadsheet, or a person in the conclave would like to see the spreadsheet and thought that some members of the community might be interested in seeing the spreadsheet. So that's that. And then...
If the committee was interested in seeing the spreadsheet, could it be produced?
No trouble. Yep.
Okay. There was an agreement that the analysis used weather from a particular year but did not examine other wind conditions that could be found in the long-term weather data.
Yes.
What are the implications of that in your view?
The implications of that are pretty minor in my view. Firstly, this is a fairly stormy period. Secondly, that we find, now this is looking at Port Arlington, not at Geelong, the winds from year to year, at least for the years 2017 to 2021 were very similar. And thirdly, even if the weather is worse, and significantly worse, not a little bit worse, then there's an adaptive management program. So that the problem of very poor weather falls upon the contractor, not upon the environment. That is the whole point of the adaptive management program, that we have a target for the environment which we meet. And how you do the task has to be adjusted to meet that target. So saying, oh, well, here's what would happen. So if you did 20 years, then 10 of the years would be better. What would you do then? Well, nothing. Make the dredge contractor happier. 10 of the years would be worse. The ones that are slightly worse don't make any difference. And then you've got the worst. And then the worst is, well, the adaptive management program will have to be applied 3 times. So that's the dredging contractor's problem. So the dredging contractor, in making his price, will make an allowance for bad weather, right? And so in our view, going through and doing that analysis helps the dredging contractor, but doesn't actually change the environmental outcomes.
Thank you. The next topic in your slide is your response to the peer reviewer. We might try and wrap this up as quickly as we can. The first slide is summary of first peer review conclusions. Do you see that?
Yeah, I have got that. And look, they were quite largely positive, right? Saying the assessment of existing conditions is accurate and comprehensive in relation to the values relevant to the assessment. And the regional hydrodynamic modelling is sound, and the model reflects the observed currents. And the near-field modelling enables a better understanding of the effect of the FSAU, which is minimal, on the dispersion from the diffuser. And the reruns of the entrainment and sediment transport provide a better understanding of the potential environmental effects. The impacts assessment methodology presented in Technical Report A, including the 14-day averaging, appears sound. And the conclusions drawn are sound. So at that point, they left us with a couple of questions, but at this stage you thought, well, things are going pretty well. And the 2 questions they left us with is, we couldn't find the comparisons between the model and the measurements. Some of those were in there, which is the wind plot, but because the report had been reorganised in relationship to their comments, it wasn't where they expected to find it. So, okay. We provided that. The second thing is they didn't agree with the statistics, and I don't think we have ever achieved agreement with the statistics. With
statistics, you mean the comparative exercise between seagrass coverage within the plains.
That's right. Yeah. Yes. Yes. Nobody in any of the peer reviews or the expert reports has agreed with the statistics, or the mathematics professor actually. Neither he doesn't agree either. So there's. But they don't agree with each other. So that's why our view is you need to look at the diagram, make up your own mind, because really there's a whole lot of statistical tests that you can use. And if you say, I just compare this batch of 400 measurements with that batch of 400 measurements, they're the same. Now.
Did you say earlier this morning on that point that there was disagreement about the statistical method used, but there was agreement about the results?
Yes, there's agreement about the results, but there's not agreement about the test.
From our perspective, our task is to assess whether the project will have significant environmental impacts or not, or whether they're being effectively managed.
Mm-hmm.
What's the relevance of the disagreement around the statistical test if there's agreement around the result?
Well, no relevance for making that decision. But if you're trying to decide what is the right statistical test, you'd have to think about it a lot.
Okay. Thank you.
And yes, so that's that. And then there was a subsequent Stantec response because the ISA wrote a letter to them and they responded. It's written by different people, and it didn't take the holistic view that was in the first peer review, which involved looking at the hydrodynamic modelling and reading technical report A. It had some, what I would say, minor issues. So it said, oh, well, you should have tested the models before the deployment. But since the mussels, not the models, should have tested the mussels before we deployed them. But since the mussels had no contamination, it didn't really matter much whether or not they had a little bit of contamination before we deployed them, that after they'd been there a month, there was no contamination. So there was no reason to go back and say, well, why is it contaminated when it's not contaminated? The second point was we should have collected more eDNA tests and samples, and I think that's irrelevant to running a particle model. I mean, if we'd collected more, instead of 14 fish, we found 17 fish, but unless we found that the fish were not breeding in the seagrass, that wouldn't change anything. And it certainly wouldn't change any of the results of the particle modelling. The third one was a discussion about how many control sites we should have and whether the two sets of control sites in the Ramsar area were all the same site or not, right? And that's a philosophical view that we don't believe they are. Our expert advisor doesn't believe they are, but Stantec believe they're all the same site. So I can't change that. That's just what they think. And the fourth comment they made two other comments. One was about leaf length, and we shouldn't be measuring leaf length, but we weren't measuring leaf length, so I didn't understand what that was about. And the other one was we should have done a two-sided t-test, but we did do a two-sided t-test. So at this point, I couldn't follow what they were commenting on. So I'm not sure that that subsequent response added any light to anything.
And you're right to say that your response to the most recent Stantec reply to the IAC's questions is the second report that identified at the start of the day. Is that right?
Sorry, please repeat that.
Your response to the most recent comment from Stantec is documented within the second of the two reports you identified at the start.
Yes, that's correct. That's correct.
Okay, well, look, let's move on. There's a couple of slides remaining.
Yeah.
And I invite you to address those in short terms.
Thank you. I'll do this as quickly as I can. This is a simplified schematic diagram just to make sure we're all clear about what's happening. So the top line is the existing situation. Water's drawn from Corio Bay, goes through the refinery, used in the heat exchangers, comes out those three discharges, and there's a little one at W2. And typically it's 10 degrees warmer with 40 microgram per litre of chlorine, right? That's what happens now. With the FSAU operating at full capacity, it cools the water by 7 degrees. That cooler water goes through the refinery, and therefore the 10 degrees turns into 3 degrees, right? It gets cooler. And the 40 microgram per litre chlorine stays the same, right? Because the refinery still operates their own chlorination system to add chlorine so that where it comes out, it's 40 microgram per litre. So no change to the chlorine. And that's that slide there, which we've discussed. It'll be the same in the future as now. Lower temperatures, different in summer and winter, but the temperature fields get smaller. And that's it for my presentation, apart from my suggestions on the mitigation measures, which I suggest there should be no dredging from September to January. Now, I know there are a range of opinions. I'm just giving my opinion based on our field studies and the views of our team. And secondly, the sediment curtain would be best located almost parallel to the current in front of the refinery shore seagrass, because that would protect the seagrass that's most exposed to elevated turbidity, and not around the dredge. Thank you.
Thank you. No further questions.
Okay. Now, we had an indication from the EPA of, I think, 10 to 15 minutes.
That's right, yes.
And 2.5 hours from the school. So we're obviously not going to get through all of your cross-examination today.
No.
I think we will...
Obviously, that was an estimate.
Yes.
But can I enlighten you about our view about cross-examination in light of the length of the evidence in chief?
Yes.
So what our learned friend has done is a series of effectively footage. He's asked the witness a bunch of questions about what is in Dr. Edmonds' material.
Mm-hmm.
I intend to triage our cross-examination because that absolves me of the responsibility of doing footage in that way, and to focus our cross-examination on matters that are more discrete. I am, though, I haven't interrupted or suggested that the evidence in chief should be shorter because this is complex material, and it seemed to me that you were assisted by it, hearing the evidence properly. Of course, we think the same opportunity should be given to Dr. Edmonds, and indeed, rather than cross-examination being the, highlight of the hearing, it really should be the experts talking to you about what they think. So what we propose to do is to cross-examine for a bit this afternoon, pull up stumps, triage, and try and finish our cross-examination within an hour in the morning.
Okay.
We're conscious that both from our experience of the last hearing, but also from this hearing, that the committee has its own questions that it wants to ask, and that they might be extensive both in breadth of subject area but also in time. And we are favouring completing the case in evidence by Thursday as compared with dotting every I and crossing every T in cross-examination.
Mm-hmm.
So that's our approach, but I want to share that first on the record so that it was clear. I've discussed that approach with our learned friend, but I just want to share that with you at the outset.
We'd actually discussed that over the lunch break as well, and we're a little nervous about if we think in fairness we do have to give Dr. Edmonds the same amount of time as Dr. Wallace has had, and how that would impact on cross-examination and our Thursday deadline.
I mean, I have really been thinking about that actively.
Yep.
The committee indicated this morning that it wouldn't adopt the approach that it adopted with other witnesses. I must say, I'd wondered whether or not that approach might be, if not as appropriate in this instance, probably more appropriate, and wondered whether or not hearing Dr. Edmonds in chief now, instead of waiting until after cross-examination and then us cross-examining at the end, might not be more useful.
Have you discussed that?
I have not discussed that with my learned friend. The reason that I raise that is because if I'm to be cut off at some point, I'd rather my cross-examination cut off than you hearing what Dr. Edmonds thinks.
We won't cut off Dr. Edmonds' evidence in chief as long as it doesn't go beyond the amount of time that...
Well, I think he should be less because obviously Dr. Wallace has had to deal with 8 recommendations, not a lesser number. But when I say cut off, I don't mean that you would deliberately curtail the proper presentation of our case, but rather that the exigencies of the time of year and the amount of time left put us under pressure to complete. That's what I'm really concerned about.
Okay. Look, what we're going to do is we're going to let the EPA cross-examine Dr. Wallace. We're then going to have our afternoon break. Yes. We might get you to talk to each other about that proposal of going straight into Dr. Edmonds' evidence in chief, and then we can revisit that after the break.
Yeah.
Sorry, over to you, Ms. Chorn.
Thank you, Member Carlisle. Good afternoon. My name is Ms. Chorn. I act on behalf of the EPA, so that's the context from which my questions will be coming. I just want to focus on your review of the mitigation measures. So as I understand it from your witness statement and from your presentation, that was part of, a smaller part seemingly, but that was part of what you were instructed to do by the proponent. Is that right?
Yes.
And so out of fairness to you, I want to put to you some of EPA's recommendations or amendments to the mitigation measures and seek your comments on those. One of the recommendation 1 made by the EPA concerns mitigation measure 5, which provides for turbidity monitoring during dredging activities. And EPA recommended some amendments to that to provide for concurrent light attenuation monitoring in conjunction with the turbidity monitoring. And the proponent proposed a mitigation measure 5A in response to that recommendation by the EPA. So I just wanted to, I'm going to attempt to share my screen and put that up for you, Dr. Wallace, so that I can get your comments.
Should I turn this off then?
Oh, thank you, yes. Let's see.
Is there a document number that you have there, Ms. Chorn?
Yes, so I'm going to the day 1 version of the EMF document, which is document number 48.
Yep.
Oh dear, it's not liking my system settings. Ms. Hall, maybe you might have better success in bringing up the document 48, which is the proponent's day 1 EMF mitigation measures. Sorry, sometimes technology works and sometimes not so much. I'm indebted to Ms. Hall. She's much better at whizzing through documents and screen sharing than I am. Thank you. The proponent's proposed mitigation measure 5 MEO5A is the EPA is content with that. Did you have any input into drafting that updated recommendation?
I'm not sure.
Okay, fair enough. That is an absolute fair enough answer. I believe it is PDF page 17.
But in principle, we propose monitoring light and turbidity next to each other anyway, so that's not good.
So here it is up on the screen for you, Dr. Wallace. So it's prior to construction, so it calls for turbidity and light attenuation monitoring at the edges of the seagrass. During, I probably should have been more specific, during the dredging operations or the dredging phase of the project.
Okay. Well, my only suggestion is that you instead of saying the edges.
Hang on, you can't whisper it to him while he's giving evidence.
Oh, sorry. Look, I agree with monitoring turbidity and light simultaneously at the same place.
Yes.
I agree that it should be slightly offshore from the Ramsar zone.
Yes.
And since I'm not sure where the edges of the seagrass is, because the outer edge is pretty diffuse, I would suggest we say the 3-metre contour.
Yes, okay.
Which is offshore, the 2-metre contour.
But you agree with the general proposition that...
I agree with the general proposition.
That it would be prudent to monitor in conjunction with the turbidity, the light attenuation?
Yes.
Okay, thank you. The next recommendation that EPA made, I'll put it to you out of fairness so that you understand where I'm coming from, relates to a mitigation measure directed at monitoring or assessing the operational impacts of the project. So moving on from the dredging phase now into assuming once the project is in its operational phase, the EPA is of the view that there should be a mitigation measure dedicated to the provision or ensuring ongoing monitoring of the impacts that this project is likely to have in the marine space. And you would agree with me, wouldn't you? As you started your evidence in chief, you said one of the primary impacts of this project is on existing discharges, correct?
Yep.
And you said there were 2 tensions there, one being rising temperature and one being the discharge of chlorine, correct?
Yes.
So the EPA is recommending a mitigation measure that provides for ongoing monitoring of those impacts throughout the life of the project. So if I could ask Ms. Hall to please screen share the EPA's opening submissions. This was the the first time that the EPA put forward this recommendation. So out of fairness to you, I'm just putting it to you in the way in which it's been put to the proponent and to the committee as a whole. It's at paragraph 57, please, Ms Hall. I'm actually not sure what document number EPA's opening submissions are. I'm sorry, member. Ditto.
IAU, Deakin Regions.
I've got 68.
Yeah,
Thank
68, yep.
Thank you. So our it's called amended recommendation 2, but I won't go into that. But the recommendation in general terms calls for operational impacts to seagrass and plankton to be measured and where possible mitigated as a new mitigation measure, and that the proponent identify suitable thresholds based on a baseline monitoring of seagrass and plankton. And at 58 we say that the additional measure should focus on how impacts to seagrass associated with the FSRU discharge in the nearshore area and impacts to plankton associated with entrainment within the FSRU intake. And we indicate that it's for the proponent to identify suitable thresholds. So I appreciate that it's not in a perfect form of words that that may find its way into the EMF, but I assume you agree with me, wouldn't you, that the general idea of having some sort of ongoing monitoring of these marine impacts throughout the life of the project is a prudent one, wouldn't you?
Yeah, look, it sounds to me like it's part of your general environmental duty to have an idea as to what impact you're having or not.
Yeah.
And if you have one, to take some action to mitigate it. So the principle sounds fine, and yeah, I'm happy with that.
Thank you for that indication. Those are the matters.
Okay, we'll take our afternoon break, but it would be useful to get, when we come back, to get a sense of how long we think all of this is going to take. So how long, Mr. Finanzio, you think you're realistically going to need to cross-examine Dr. Wallace, how long you think Dr. Edmonds' evidence in chief is going to require, and to the extent that you are able to predict in advance of his evidence in chief how long you think you'll need in cross-examination. I think that will just really help us map out the process between now and Thursday. So we'll see you at 25 past. Okay, we might start with you, Mr. Finanzio. Any update on timings?
So if I start now, we'll get an hour in.
Mm-hmm.
That'll give me about an hour and a half tomorrow. I've spoken to Dr. Edmonds, and we think that he can probably do his material in an hour and a half.
Mm-hmm.
Leaving aside things I can't know about, which is how long your questions might take, that still leaves us with a day and a half for Mr. Chessel's cross-examination. And your questions of both the two witnesses on this area.
Mm-hmm.
I think we both agree that we're happy to do whatever would suit you best, but that's I think a fair estimation of where we're at. Obviously, I can't know whether I'll be exactly an hour and a half in the morning.
Yes.
I'd be open to starting a half an hour earlier. I can't sit later tonight.
Yep.
But I'd be open to starting a half an hour earlier tomorrow.
Okay. And Mr. Chessel?
Yeah, just to add to the timing, we said 2 to 3 hours, and that's still my estimate. It'll depend what, I mean, I haven't seen the presentation yet. I'm not sure
Yeah.
to what extent certain things are pressed or not. But even with that estimate, it does seem that with the additional 2 full days, there is still considerable time for committee questions. So we'll do whatever you want, obviously, to facilitate this in any way you want. But it seems to me that we are still on track to finish within 3 days.
We think we are too, and we think it would actually be less confusing for us if we could just do the cross-examination now.
Yeah.
But what we will do is go back to asking the committee's questions to both witnesses. We had sort of thought it just could be too much because there's
so much material.
There is a lot of material. It's fair to say that a lot of the questions we had for Dr. Wallace have probably been addressed through the evidence in chief. So in that sense, you were on the money that it was of assistance to us to have that longer evidence in chief. Look, we might revisit that tomorrow after you've finished your cross-examination, but at this stage, I think we should get through in the next 2 days without anyone stressing about time if we do it in that order. So we'll hand over to you, Mr. Finanzio.
So just so it's clear, we'll do Mr. Finanzio, then we'll hear from Dr. Edmonds. I'll cross-examine Dr. Edmonds, and then they'd both come back to answer the committee's questions.
That's the plan.
The question that we should also possibly ask is, your availability. Are you available to be here both days?
I am. I have had my day off on Monday, thank you, and I'm willing to be here for 3 days.
Okay.
But I'd like to get off at a known time on Thursday, if that's all right.
We had understood there was some important agricultural business to attend to, but we take it that's been attended to.
No, the canola has been harvested and is in the silo.
Okay.
The wheat has been harvested and is in field bins because there was a total fire ban. And the wheat is still sitting up there ready to be harvested. So I just like to know when I can get away.
Yes.
Not that there's any, I mean, if it's 4:30 or whatever is the agreement.
This is on Thursday.
On Thursday.
Yes.
Just so that I can plan others' schedule.
Yes. I don't think we're going to have any problems in that regard.
Right. Okay. Thank you.
Okay. Thanks, Mr. Finanzio.
All right, thank you. Hello, Dr. Wallace. My name's Adrian Finanzio and I'm asking questions on behalf of the school. I think at the beginning of your evidence in chief, you outlined your involvement in the project and I think you used the descriptor project manager, correct?
Yes.
It's right, isn't it, that you're not a hydrodynamic modeller, but as Dr. Yates said yesterday, you provided him with assumptions about the model that he was to prepare and you reviewed the work that he produced.
That's correct, yes.
It's true also that you are not a professor of statistics and you sought advice from Professor Keogh at the University of Melbourne in relation to statistics.
That's correct.
Correct. We have an appendix from you which outlines what you say he told you about in relation to your questions, but we don't have any information provided by you to him. That's right, isn't it?
That's correct.
Did you provide information to him as to the task he was to undertake in writing?
No, I didn't.
I see. That's the answer to my question.
Yeah.
It's also true you are not a dredger.
That's correct, although I have supervised dredging on behalf of others and been on dredging.
But in relation to your preparation of the EES, you specifically sought advice from Boscalis.
Yes, because they have dredged Corio Bay before.
Yeah. And you record what they have told you, but again, we don't have your instructions to them, do we?
No.
Finally, you're not a marine ecologist. That's true, isn't it?
That's true.
On the last occasion, Dr. Chidgey, who is one of your colleagues, gave evidence in relation to marine ecology, didn't he?
Yes, he did.
And finally, you're not an expert in seagrass, are you?
No, I employ others for that task.
Indeed. You said in answer to questions before that you've spoken to people about seagrass issues, but you, in giving your evidence, you reached the limit of your knowledge. Is that fair?
There's certainly a limit to my knowledge on seagrass, yes.
Your role here was to gather together all of those strands and prepare the SEES as a summary of, in particular the CEE report, as a summary of those inputs, correct?
Yes.
And you made editorial decisions about what should be included and what didn't need to be included. Is that correct?
Yes.
I want to ask you some questions about your presentation. Can you go to image 12 of your presentation? You see there's the heading.
Do you want it on the screen?
It doesn't need to be on the screen. I think we can move more. We can move more quickly. I think we can move more quickly if people just. Oh, sorry, I didn't hear. It would help you. Okay. Yes, please. 12. Do you have that there?
I think I do.
It's up on the screen now.
Not sure why it's not there. Oh. That's the one?
That's the one, the graph.
Yes.
Which graphs seagrass cover in North Corio Bay across those years. Do you see that?
Yes.
I will not find that graph in the SEES, will I?
No, but you find text on that graph.
I see.
Which I'll point out to you if you like.
But that image is a new image.
The image is the image from which the text was written.
I see.
But the text actually quotes some of the numbers in that image.
I see. And underneath the image, the port maintenance dredging of approximately 200,000 cubic metres, 2014, 2015 and 2017, and soon.
If I could just remind everyone online to make sure you're muted again, please.
My question is, what is the source of that statement?
Okay, there is a image in the report.
Yes.
Which I'll try and locate for you.
You don't have to do it now. You could advise me of that later.
Okay, there is an image in the report that shows previous dredging in Corio Bay.
No problem. If you can just,
come.
At some point before we finish up today, if you could direct me to that, I'll have a chance to ask you questions tomorrow about it.
Sure.
Can you go to PDF 16 of the presentation, please? That is a new image, isn't it?
Yes, that is a new image.
That's what I'd describe, but you tell me if I'm wrong, as an ecological model, correct?
It's a variation of the image in Dr. Edmonds' report, really.
Yeah. Can you just tell me if in that image there's a link there to migratory birds?
No. I can tell you there is not a link there to migratory birds.
See? And can you tell me this? I think you said in evidence in chief that these matters were discussed And that they were documented by internal memorandums between you and your team?
Yes, the risk assessment of, well, there's another group looking at migratory birds, so that's question 9, and
Yeah.
we only addressed 1 to 8.
I'm not asking about migratory birds now, I'm asking
Yeah.
about the document itself and its content.
Okay, that, yes, we internally discuss what we think we should do, but it's fair to say I make the decision in the end.
Not to include that discussion or a document like this in the report.
No, there's quite a discussion of it in the EES.
Right.
There's quite a lot of pages of the risk assessment in the EES, and so this simply follows the same line,
Yeah.
and adopts the conclusions in the EES.
Can I ask you about page 17 of the document?
Of this document?
Yes.
Yep. That's intertidal algae?
Yes.
Yes.
Is intertidal algae mentioned in the EES in this way?
Probably. But I would have to have a look, yes.
See. These images included in the EES?
No, they're not included in the EES.
Sorry, Mr. Fernando, a couple of the responses that we've just heard, the answers were EES. Just want to confirm
SEES.
that the answers were EES as opposed to SEES.
SEES.
So,
thank you.
Can we just clarify
Okay.
question and answer?
So the risk assessment of the various environmental sectors is in the EES, not the SEES, and the EES addresses intertidal algae, but the SEES may or may not. I would have to have a look.
All right. Okay.
And sorry to interrupt the flow, but you provided, in response to my questions earlier today about whether any further survey work was undertaken on those elements to better establish the existing conditions, you provided a response that went along the lines that you did do additional survey on fish, sea urchins and intertidal algae, but didn't on a bunch of other stuff.
Yes.
And then you said, technical term stuff, sorry, other things. You only looked at elements of the ecosystem that are potentially impacted by the project, and then you concluded by reeling off a list of species, and the comment addressed in the risk assessment of the EES, but I can't find that reference, and so again, homework, possibly tomorrow, can you provide a reference to us to figure out where that list that you read out is in the EES risk assessment?
Yes, I can.
Sorry, Mr. Fernandez, but it was a convenient time to...
No, that's very helpful. Thank you. And on PDF page 18, you said there on that page that selected seagrass cover to assess impacts of existing discharges because it, and I'm taking that to be seagrass cover, is a good measure of seagrass condition and productivity.
Yes.
And you mentioned, my recollection is, you mentioned other studies in Port Phillip Bay that have used seagrass cover and recommended it as the best measure of seagrass condition.
Yes.
And I think I caught it, but can you just remind me what those other studies were?
Yes. That's in page 334 of the SEES.
334. Yeah.
And 333.
Thank you.
And 335.
And you mentioned, I think it was some Victorian studies. I think you mentioned the name of the studies.
Blake and Ball, yes. And there are a series of them.
Say again?
Blake and Ball.
Blake and Ball. And what year were they?
Well, Blake and Ball is 2001. That's the seagrass mapping of Port Phillip Bay.
Yeah.
And then the other relevant one is, or relevant, is Ball 2014. And the principal component analysis decision is in Hurst and Blake 2012.
And can I just ask you, just bear with me for a minute. That's it. Those page references you just gave me are the SEES page references?
Yes.
Thank you.
Technical report A.
Yes, technical report A, sorry, yes. So,
PDF page 48, 202, 220. Refers to Blake and Ball.
Oh, yes, I see. Thank you.
and if I may direct you to page 335 of the SES, 1, 2, 3, 4, 5th paragraph.
$335. Yes, thank you. And the last question about your presentation, which I just wanted to ask you about, is page 45.
Page 45.
Where you include the comparison between the predicted increase in average suspended solids and the Lawson and Treloar 1997 model. Do you see that?
Yes, yeah, those are the two plots or the table?
The two, I'm in page 45 of your presentation.
Yeah, this doesn't, do you mean this one or the one above?
The one that's up on the screen.
Yep, right.
Now, I just want to understand that document, that those images appear in the technical report at page 145. The plots, PDF 145. There are two images in the technical. Are you working off a hard copy? Are you?
Yes, sorry, I have a hard copy.
8/130. PDF 145.
8/130, yes.
Yeah. You see there that the image that you've included in your visual presentation for today is the first image on that page.
Yes.
Lawson and Treloar model 1997.
Yes.
That image isn't in the 1997 report for Lawson and Treloar, is it?
No.
What's happened is that the figures from the Lawson and Treloar model described in the 1997 report have been modelled by someone. Am I right?
No. The Lawson and Treloar model also had a disposal point in the middle of the bay, which had another high turbidity.
Yeah.
So this is the Lawson and Treloar model around the dredging site, unaltered, but deleting the disposal site.
Right. Who produced this image though?
We did.
Right. So I won't go. I've got a copy of the Lawson and Treloar document. I won't find this image in the Lawson and Treloar document. Will
You
I?
won't find exactly this image, but you will find the 5 contour and the northern, western and southern part of that image. But the eastern part has been cut off.
Yes, and the further refinement that's in the image below?
The further refinement was, you'll recall that I spoke about adding an extra component to the sediment fractions. And so this image showed how much impact that had. So if we hadn't included fines, that would be in a darker 2 milligram per litre shape.
Yes.
But by including fines, which we have included, that makes it larger.
Thank you.
I mean, it's just to illustrate to the reader the significant impact that adding that extra component made to the results.
But the depiction in the image is of a model prepared by who?
By Dr. Yates.
Right.
Well, and that image was prepared by Dr. Yates. The right-hand image is a Lawson and Trelaw image with the disposal site cut off.
I see. I won't find that image in Dr. Yates's hydronumeric evidence, will I?
No, because he didn't do it. This is actually Lawson and Trelaw model, not Dr. Yates' model.
Right. But Dr. Yates prepared the image.
No, someone in our office prepared that image.
I see.
We took in the project case, they do the dredging and they take it to a disposal site in Western Port Phillip.
Yep.
In the Lawson and Trelaw case, they did the dredging and they took it to a disposal site, which is in Corio Bay, not very far away. And so you'll notice that in that image, in their report, there are 2 5 milligram per litre contours.
Yep.
And we cut off the eastern side to say, look, that's not the dredging, that's the disposal site.
I see. All right. Thank you for that clarification. I want to ask you some questions about your responses in relation to recommendation 1B.
1B.
So can we go to page 51, PDF page 51, or page 336 of the technical report A?
Yes.
This is the map of seagrass distribution in northern Corio Bay, right?
Yes.
And the legend at the bottom right-hand corner describes the different zones within that map.
Yes.
So the way this works is that if I look at the blue area, for example, what this is meant to represent, this drawing, is that I will find similar conditions in the blue area wherever the blue area is located.
Yes.
And the blue area is described as nigricollis with scattered althenia.
Yes.
It's right, isn't it, that the person who looks at this map properly assumes that the qualities or the condition which one finds in each of these designated areas should be broadly consistent. Do you agree?
Yes.
Beyond this map and this legend, there is no definition of these zones otherwise in the SEES, correct? This is where I find the definition of these zones and their content.
Yes.
The categories that are described here are not uniformly do not appear in nature, in reality, as uniformly as depicted here, correct? So take the orange area, for example. I will find areas of intertidal muelleri and rocky reef as well, won't I?
Well, yes, you'll find small bits of rocky reef, yes.
How was it that the delineation of the lines on the map were settled upon?
They were settled upon on the basis of the distribution of the various species with regard to depth, the results of the towed camera surveys, and trying to integrate that into a single map.
Right. So if I just go forward to page 338 or PDF 53, they show the tow camera surveys, don't they?
Yes.
And the tow camera surveys on the western end of Corio Bay, some emerge radially or at right angles from the shore. See that?
Yes.
And some run along the parallel or close to parallel with the shore.
Yes.
On the eastern side of the northern reaches of Corio Bay, the tow cameras run exclusively parallel to the shore, don't they?
Yes, they do.
So if I go back to the image where on page 51 I've got orange area, yellow area, blue area and dark green area, there's no way that the camera tows can inform the delineation in the mapping. That's right, isn't it?
No, the camera tows also were converted into species distribution with respect to depth, and so that does inform you.
But the cameras only went along a certain path, didn't they?
Yes, but if you take that line of logic, then I could only have a map that is where there is a camera tow. In other words, unless there's a camera tow over every single point in Corio Bay, you can't make a map.
Well, you did it at 90 degrees from the coastline on the other side, didn't you?
Yes, I did, but if I look at figures 9.6 and 9.7, that helped me do that task.
9.6 and 9.7. Which page is that?
Well, in my case, 9.143, 9.144.
Having trouble finding you. Nine 133 and
9.143.
143.
PDF 158, I think.
Yes, I see. I see. It's not a map there, is it?
No. It is the depth range of Nigrocaulus and the depth range of Halafilla in Corio Bay. So
right.
This is where you find seagrass as a function of depth.
Right.
And so that helps inform how you put together a consolidated map.
Okay. Can I just be clear? That's not abundantly clear from the SEES that that's how you've done it. The lines of delineation that you've included here, it seems the lines of delineation that you've included between the two zones or between the four zones that you've described are not solely based on depth and bathymetry, are they?
They're based on a combination of the towed camera images, this is page 335,
Yeah.
near map images, drone photographs, ground truthing and diver observations.
I see.
So all those things we use to inform the map.
It's right, isn't it, that the only way that we can check the conclusions that are represented by the map is by going back to the photos and by going out and having a look ourselves?
Well, no, you could also look at the near map images, and I think we've also provided the drone photographs,
Okay.
so you can look at all those things.
So we've got the tows and we've got the drones.
Yes.
There were 4 campaigns for the tows, weren't there? August 23, the 18th of October 23, November 2023 and January 24. Correct? 4 campaigns for the
I'm
tows.
not certain about that, but yeah, there are a number of campaigns, yes.
You're not certain that it was only the 4?
I'm not certain it was only the 4, yes, because there were other smaller surveys done at times.
Well, you're aware, aren't you, that you were asked to provide the camera tows that were used in preparing the report, right? You're aware of that?
Yes, and I certainly provided.
And you prepared the material that came to our client,
Yes.
didn't you?
I did.
You did that personally?
No, I didn't. No, I employed people to do that.
I see. And there were 3 campaigns for the drones, weren't there? Or were there more than 3?
I'm sure there are more than 3 because we have drone photographs of the mouth of Limeburners Bay and other places
I see.
that were not used for the seagrass cover surveys, but we also collected extra drone photographs to look at other parts of Corio Bay.
So you're not confident that we've been provided with all of the material that we asked for?
What I was asked to provide was copies of the camera surveys, the major camera surveys, which I provided, and of the drone photographs that we used for the cover comparisons.
Yeah.
That's what I provided.
Okay. Well, I've put to you that we've got 4 tows.
Yeah, well, that's probably right. Sorry. I mean, I just don't want to say there were only 4 tows when that is a question I can go and look up and get the correct answer.
The tows surveys that were originally provided were provided to us as PDFs, weren't they?
Yes, they were.
You went to the trouble of converting them to PDFs.
Well, actually, your request was in the form of PDFs.
I see.
So I went to the trouble of employing someone to make PDFs to give you what you asked for.
I see. Subsequently, they were provided as JPEG files, weren't they?
Because you asked for JPEG files. So you asked for JPEG files, I give them to you, even though they're enormous files and a lot of trouble.
Have you independently looked at those JPEG files?
No.
Are you aware that JPEGs can contain position data that you can use to plot the position of the photo in a map?
I'm not aware of that, but I understand that there is a separate file of positions of the photographs which was provided to you.
You didn't do that exercise in the preparation of the SEES, did you? Geoposition the photographs.
Well, I think we did, because that's where these figures here come from, but I don't personally do it.
Okay.
So these figures that show coloured dots on the map, which are the camera surveys plotted in position.
All right.
I'm assuming the person employed to do that does that.
All right. Well, I want to show you what we got, because I want to put a couple of questions to you about it. Can I ask Mr. Tobin to share from the marine ecology data the position fixes?
Could I just clarify, are we talking the camera tow images?
Camera tow images.
Yep.
So this was provided to us as a PDF which contains the date and time that the photo was taken, the photo file, and the easting and northing of the photo.
Yes.
The JPEGs that were provided to the school did not include this data in them, but rather we were provided with this PDF from which you could work out where the photos were taken from. Do you understand?
Yes.
Now, I'm right, aren't I, that none of this data is recorded in the SEES? This is all background work.
That's correct. Well, of course, the summary diagrams are recorded in the SEES,
Yeah.
but no, you don't. I mean, those I can't recall.
Yep.
But I did skim through those files of PDFs that were sent to you just to check that there were files of hundreds of PDFs.
Yep.
And so to that extent, I checked that we were sending you what you had asked for. But that would be way too much material to put in a document.
Yeah. Now, if I go to the document, if I go to the technical report A at page 51, and look just first of all at the green area.
Page 50, you mean the map again?
The map, yeah. 336 for you.
Thank you. Yes?
That's the area that's described as Halophila mixed with Nigricollis. Do you see that?
Yes.
Can I suggest to you that in that area, well, first of all, that what that description suggests is the presence of Halophila predominantly with Nigricollis present.
Yes.
Can I suggest to you that in the green mixed zone, in the green zone that is depicted on that map, which is the largest area, do you agree?
Yes.
And the area closest to the activities of the dredge? Yes?
Yes, yes.
That what you'll find there are locations where there is no mix at all. It's either all one or all the other. Do you agree?
Probably.
Where there are areas of bare sediment.
That's certainly the case.
And places where it is mixed in the way described.
Yes.
Do you agree with me that those locations have different ecological properties?
Look, they do have different ecological properties in terms of a fine level of detail, but in terms of whether or not there are seagrass there, there are seagrass there.
Yeah. I want to show you the photos, and if I can just ask you first of all, Mr. Tobin, to show image 11. Can you see that on the screen?
Yes, I can. Yes.
Can you see the screen in front of you?
Yeah, that's a
Much
bit easier
clearer
to
than
see. Yes.
Yeah. Can you see there that in that image that you've got in front of you, there are 6 images?
I've only got 5.
Pardon me, 5 images.
Yes.
And can you see that there is a G, H, I, J, K? Can you see that?
Yes.
And can you see there that what's described is Zostra nigricollis, Halophila, Halophila australis, sparse Halophila with epiphyte on mud, and bare mud with burrows and microphytobenthos. Do you see that?
Yes.
Would it surprise you to know that all of these came from within the green area?
It doesn't surprise me in the slightest, because that's exactly what I expect to find in the green area. That is a mixture of Nigricollis and Halophilia and bare areas, which is what I said would be there.
And if I take you to, if I can show the witness image 12 or slide 12.
Slide 12.
Can you see that now? Maybe have to blow it up.
Thank you.
Again, all of these images come from within the green area, but in November. Do you see that?
Yes.
Do you agree with me that what these images depict are different ecological communities with different properties?
In one sense, they are still a mixture of seagrass.
Yeah. And can I show you the image 10, Mr. Tobin?
Are these images taken by Dr. Edmonds?
No. These are images from the camera toes.
Right.
Can you see there from the 20th of January, I'll just ask you to look at that image.
Yes.
See that? Again, these show, I suggest you, different ecological communities where there would be the presence of microphytobenthos, there's some mixture, but then no mixture. Do you agree?
I agree, but then I would further suggest...
Well, just hang on before you suggest anything.
Okay.
I want to show you, just to confirm things, that Dr. Edmonds used the data provided in the PDF to plot the locations of these communities. And if you could just show survey 2 and 3, image survey 2 and 3. Can you see the letters there in that image?
Yes.
They all appear in the green zone, don't they?
Yes.
And what I want to suggest to you is that there is...
Sorry to interrupt. Can I just ask, is this an image within the witness statement?
No, this has been produced.
Oh, so he hasn't seen this image before?
No, he hasn't.
Ah.
These
When's it been produced?
It's been produced now. I'm putting to him...
Ah, well, give him a chance to explain. You think you should explain what it is?
I'm going to explain what it is.
Okay.
Okay. You see this image here? Can you see there that the letters are marked with dots?
Yes.
Can you see those? Those dots, those letters correspond to the photographs that I've just taken you to.
Yes.
Which photographs? All of them?
All
or
of them.
some of them?
All of them except... Just bear with me. All of them except the photographs from 1 October 2023, which I think are G, H, I, J and K, because we haven't been provided with the... we haven't been able to ascertain the locational data from the PDF that we were provided with. So these dots on the plan, on the map, reflect the photographs taken in November and January in the camera toes. You need a moment to look at that, Dr. Wallace?
And am I seeing a series of photographs in the green area which have some halophilia, some nigrocaulus, some bare sediment and some mixtures of the two?
Correct.
Right, okay.
And I suggest to you that what that shows is a significantly greater degree of diversity across the green area than the simple designation given to it by you in the map on page 51 of the SEES.
Well, what we are saying is in the green area you will find Halophila, Nigritalis and bare areas. And isn't this the same? I mean, you've provided things in a bit more detail because you go from point to point and it's slightly different at each point, but I think we said that too.
Yeah, I want to suggest to you that the differences depicted in these photographs suggest different environmental conditions in each of those locations.
Well, to the extent that they are more or less on a contour, the light must be similar in these locations, mustn't it?
I don't know.
All right.
That's your assumption.
It probably is, yes.
Okay. Now, the purpose of this map on page 51 is to show the existing biological condition, isn't it?
Yes.
And also then to map, you prepare maps of what the physical impact will be of the project against these conditions.
Yes.
You agree? This is so that you can compare where the physical impacts overlay the existing biological conditions.
Yes.
Now, can I suggest to you that it's normal to include the median predicted impact, but also the 95th percentile to understand the full footprint of the proposed works?
I think that's completely
what
wrong.
Works? What,
Pardon?
what impact and what works?
Impact of the project.
No, but in what respect? Under what you can't just say median in 95th percentile. You need to identify what relevant stressor you're talking about, under what scenario.
Well, let's just deal with it because I'm dealing with this now. Let's just deal with dredging. I mean, the short point is it's normal to depict in maps of this kind the median predicted impact of all of the stresses and the 95th percentile of all of the stresses, isn't it?
No. I have gone to some trouble to explain why I think using the 95th percentile for this situation is not helpful.
Yeah.
And therefore I would not agree that it's normal. If I was assessing, as I have, a 2-year program in Gladstone, then we did look at the 95th percentile because it's a long tidal channel. The hydrodynamics are quite different. The biology is quite different. The sediment distribution pattern over time is quite different. And in that case, the 95th percentile was the appropriate measure, but it's not the appropriate measure here. So I haven't agreed, and I do not think that is normal for this situation.
Okay. I want to ask you some questions now about recommendation 1C. And I just want to grab the conclave report. And take you to 1C in it. 1C is to be read, isn't it? It is to be read, isn't it? With the preamble, which says, undertake further...
Sorry, Mr. Finanzio. I think I'm on the wrong conclave statement. Which document number?
Oh, I haven't. The version I've got hasn't got my document number on it. It's the ecology one.
Ecology.
I'll
Yes,
tell you
I'm
what
in
it
the
is.
modelling one.
I think it's 59.
59.
Yeah.
Thank you.
Undertake further survey work to better establish the existing environment and the impacts of the existing wastewater discharges from the refinery to enable a better understanding of project impacts. The survey work should, and then it goes on to say, be carried out over a period of at least 12 months before construction or dredging starts, with a minimum of 4 sampling runs, 1 in each season, to address seasonal variability. Now, in terms of sampling runs undertaken here, the only sampling runs that we've got that you had in the preparation of the SEES were the drones, correct?
No. In terms of preparing this map, I had 20 months of sampling runs, because I have the sampling runs in the EES, which went for 13 months, and I have the sampling runs from the SEES that goes for 7 months. So I've got 20 months of camera tows and other biologist reports and inspections, and that was what I used to make this map.
I see. Insofar as the drones were concerned, you had, insofar as the drones were used,
Yes.
you had 3 runs, didn't you?
3 runs, yes.
2 in spring and 1 in summer.
Well, they weren't selected for particular seasons. But I think somebody said they were winter, spring and summer, but they weren't really. They were widely separated by several weeks just to get 3 independent surveys.
The drone runs we're talking about, though, these 3 surveys these 3 drone runs, these are the runs that traversed the same path parallel to the beach.
Yes.
From which you then analysed locations 15 metres apart.
Yes, the drone runs were used for the seagrass cover study, not to prepare the seagrass distribution map.
Yes. And a feature of a sampling run that's repeatable is a sampling run that goes over the same ground each time, correct?
Yes.
And the only repeatable sampling run that is in the EES in respect of seagrass cover is the drones, 2 of which were conducted in spring and 1 in summer.
But the drone survey was not intended to be the baseline survey. It was intended to be, what are the effects of the existing discharge survey?
Yes, I see. So the baseline survey is referred to in recommendation 1D, isn't it?
Well, I think it's recommendation 1C, carried over a period of at least 12 months before construction or dredging starts.
I see. You agree with me that you couldn't treat the tows as a repeatable sampling exercise?
No, they're not. Each tow is independent, you might say, and so they're a collective set of data.
Because you're not following the same path every time.
No, you're trying to have new paths.
And they don't cover the full year or the seasons independently, do they?
No.
Normally, it's right, isn't it, that you design the seasonal sampling and baseline monitoring so that they can happen at the same time?
If there's a big seasonal effect, yes.
And the data that you got from the drone surveys concerns seagrass cover only, correct?
Not for the whole bay, just for the areas we're looking at.
Not for the whole bay, just for the areas where that occurred.
Yes.
That sampling or those drones do not describe the ecological diversity present in the receiving environment, do they? It's just seagrass cover.
Well, you can look at the drone photographs and assess what you wish to assess, but we were assessing seagrass cover from the drone photographs.
And that's all. That's all you did. That's all you used those drones for, correct?
We also, well, we assessed seagrass rack, for example, and we assessed bare areas in the drone photographs, so it was more than just seagrass cover.
Yeah. But when you're using drones in the way that you were, you can't distinguish, can you, between different types of seagrass?
We didn't attempt to that's not true either. We did attempt to distinguish between Mullarai, intertidal seagrass, and the other seagrasses offshore, which we believed were a mixture of seagrasses.
You attempted to, but you couldn't.
No, you could, because all the intertidal seagrass is Mullarai.
Do you agree with me that from the drone surveys, it's difficult to ascertain the different habitats?
What do you mean by habitat there?
Well, the diversity, the ecological diversity in the location where the drones are taken.
No, I don't. I believe that that the ecological habitat in dense seagrass is entirely different from the ecological habitat in bare seabed.
So let's look at what you've done. Can we go to PDF of the technical report, PDF 56?
Which page is this, sorry?
I'll tell you in just a minute.
Okay.
341.
341, yes.
What you have done and what's reported in the SEES is that the drones have flown along those trajectories at the times of those surveys, and that each of the dots shown there represent a spacing of 15 metres, correct?
The drones are flown over the whole area at a height of 30 metres.
Yeah.
At a spacing where there's significant overlap between the photographs, both in an east-west direction and a north-south direction, and a composite photograph is prepared, which is ortho-rectified, which is then put into our GIS system, and then each of these points which are defined show up on the base map of that photograph. And so the photograph covers the whole area. It's not a photograph of a whole lot of little points.
And you go back after each run and compare dot for dot.
We certainly did our best to do that, yes.
And the point of classification for seagrass cover is the dot, right?
Well, except the dot's an area of 2 metres by 2 metres, so it's a site rather than a dot.
And what happens at that point is that you make a characterisation visually in the assessment that you've done of sparse, of whether or not, of the abundance of seagrass in those locations across the categories sparse, medium and dense.
Yes.
And I think you outlined before that sparse are where leaves don't touch.
Yes.
And dense you can't see sediment in the leaf canopy. And medium is everything in between.
Yes. Apart from bare.
I'm right, aren't I, that there's a very large proportion of what's visible that falls within the medium category?
You're right.
Something between 30 and 80%.
Yes.
And of course, you're making these categorisations from the zone images alone.
From the drone images.
Drone images alone.
Yes.
Do you agree with me that the delineation between sparse, dense and medium conducted in that way is difficult?
Yes, difficult and time consuming.
Yeah.
Nonetheless, I checked that we were getting a repeatable answer. So for 2 of the runs, I got a second biologist to make the classification to see how repeatable it was.
Yeah.
And it was repeatable within 1% for subtidal seagrass and 1.5% for intertidal seagrass. So, yes, it's a coarse classification system, but if you have people who are doing it regularly, different people in the same team came up with very similar results.
Yeah. These are all people in your team.
Yes.
Could I just clarify there? When you say repeatable, you ask different people to analyse the same images and come up with their own results, and then you compare those results.
Yes, if you look at exactly right. Just under this, if we slide that image up a bit, you can see an example of a section where the darker, taller bars represent a classification of dense, and the medium length, medium green bars represent a classification of medium, and the small bars represent a classification of sparse, and the brown bars represent bare. And I found several of those, and I asked different people to take the same dots on the same screen and to classify it like that. And then I applied our factors of 10, 50 and 95%.
Yes, we're getting beyond that. What I was curious about is whether it was two people performing the same exercise, or one person analysing the drone footage and another person, say, going out and ground truthing, or looking at the camera tow images to compare.
No. All the seagrass cover was made from the drone images.
Yep.
And I merely asked two people to analyse the same drone images to see if they came up with repeatable results.
Understood. Thank you.
Thank you.
It is 4:29, Mr. Finanzio.
I'll finish this topic and just a couple of questions.
Sure.
There's no mention in the SEES or the EES of where this approach has been adopted in the past?
You mean comparing seagrass cover from A and B?
Yeah, correct.
No, there's no mention in the EES, and I suppose it's not a common question to say what is the impact of a cooling water discharge on a seagrass environment. So,
can you point to any other work where this method of assessing seagrass in this way, seagrass abundance in this way, has been applied?
The Blake and Ball reports, which talk about, where do we have seagrass in Victorian coast and how dense is it and what condition is it in.
Right.
That's where the method comes from.
They were the reports you mentioned before?
Yeah, I didn't invent the method. I merely adopted the method.
I see. Okay. All right. Well, that's a useful spot to stop.
I'm sorry to do this, but when you say when you adopted the method, you adopted the classifications of sparse, medium and dense,
yes,
or you adopted the method of applying those classifications from drone footage?
Okay, I'm sure Blake and Ball didn't use drone footage,
yeah.
So it's the first.
Okay, yes. All right, thank you.
How did Blake and Ball do
it? They took photographs and they sent divers.
So, are you aware of anyone else who's ever done it using just drones?
No, I'm not aware, but in my life I found every time I think I'm innovative, it doesn't turn out to be the case.
Okay, thank you.
Can I ask there was an image put on the screen a moment ago with letters with photos. I didn't see that in Dr. Inman's witness statement. I might have missed it. Is that in the witness? Is that in the presentation?
No, it's not in the presentation.
Can we just have that file,
yeah,
if
for
possible,
sure,
so I can make reference to it?
Yep.
Perhaps along with the photographs that accompany it.
Yep.
Thank you.
I intend to tender them, so.
Okay. Anything else anyone needs to raise before we break for today? Nope. Okay, we'll see everyone at 10 o'clock tomorrow morning. Thank you.